In the stillness of the evening, when the body begins to soften into rest and the mind turns toward calm reflection, it is soothing to consider the remarkable structure within us that makes life itself possible. Beneath the skin and muscle, beneath every gesture and every movement, rests a quiet framework of strength and support, the human skeleton. It is not loud, nor is it often thought about in our daily routines, yet it is always there, keeping us upright, giving shape to our bodies, and guarding the most precious organs within. Tonight, as we explore this framework in a gentle, unhurried way, let the rhythm of the words move slowly, encouraging relaxation while also nourishing the curiosity that rests within us all. The human skeleton has long been seen as a symbol of life's underlying structure, the hidden support that allows the visible self to flourish. When you walk across a room, when you stretch out your arms, or even when you lie still in bed, your skeleton is there, quietly carrying out its work. It is the scaffolding upon which muscles attach, tendons pull, and ligaments stabilize. It is both strength and balance, both stability and motion. Without it, the body would be formless, unable to stand, unable to move, and unable to protect the delicate organs that sustain life. And yet, though it is made of hard tissue, the skeleton is not static. It is not a lifeless cage, but a living, responsive system. Bones are filled with cells that build, shape, and renew. They are nourished by blood vessels, strengthened by minerals, and supported by networks of fibers. Each bone is alive, participating in the constant rhythm of renewal that defines the human body. From birth to the end of life, bones are continually changing, growing in size, altering in shape, and adapting to the needs of the body. The skeleton is not a fixed object, but a dynamic companion, one that grows with you, changes with you, and carries your story in every line and curve. To begin with, it helps to imagine the skeleton as more than a collection of separate bones. It is a single, interconnected system. Each bone links to others through joints, ligaments, and cartilage, forming a continuous whole. The skeleton is sometimes divided into two regions: the axial skeleton, which includes the skull, the vertebral column, and the rib cage, and the appendicular skeleton, which includes the arms, legs, shoulders, and hips. Together, these regions make up the framework of the human body. They are not separate entities, but parts of a larger design, one that balances strength and flexibility, protection and motion, endurance and lightness. At birth, the skeleton is not fully formed. Many of these bones begin as separate pieces of cartilage, soft and flexible, which gradually fuse together as growth continues. This flexibility is vital for early life. It allows babies to pass through the birth canal, to bend and twist with ease, and to grow at an astonishing rate. Over time, as the body matures, these bones harden and fuse, creating the stronger, more stable skeleton of adulthood. Even then, the work of bone never ceases. Old bone is constantly broken down, and new bone is formed, a cycle that continues quietly in the background throughout one's life. This living quality of bone is one of its most remarkable features. Inside every bone lies a world of activity. Within the compact outer layers and the spongy inner structures, specialized cells are at work. Osteoblasts build bone, secreting new material to strengthen and thicken. Osteoclasts, in turn, break down old or damaged bone, recycling the minerals so they may be used again. Together, these cells maintain balance, ensuring that bone remains strong but not overly heavy, dense but also resilient. In the marrow, nestled deep within, another miracle unfolds, the creation of blood cells. Red marrow produces red blood cells, white blood cells, and platelets, each essential for carrying oxygen, fighting infection, and healing wounds. Thus, bones are not simply supportive beams of the body, but also quiet factories of life itself. As we reflect on the skeleton, we might think of its role in daily life. Consider something as simple as breathing. With each breath you take, the rib cage gently expands and contracts, protecting and guiding the lungs. With every step you walk, the bones of the legs absorb impact. The joints cushion movement, and the spine maintains posture. When you reach out with your hand to grasp something, the bones of the wrist and fingers bend with delicate precision, allowing fine control that few other creatures possess. Even in stillness, when you lie completely at rest, the skeleton does its work. It bears the weight of the body against the pull of gravity, keeping the organs in place and the body aligned. The skeleton has also been a subject of human fascination for centuries. Ancient cultures saw in it the mystery of life and death, the hidden structure beneath the visible form. Artists studied it to better understand proportion and movement. Physicians examined it to learn how the body functions, how it breaks, and how it heals. Even today, medical science looks to bone for clues about our past and our future. Bones carry evidence of age, nutrition, health, and sometimes even the stresses of daily life. In this sense, the skeleton is both a foundation and a record, a quiet keeper of memory within the body. As we move into our study of the skeleton, we will explore it slowly. We will begin with its overall structure, then travel through its two great divisions, the axial skeleton, which forms the central core, and the appendicular skeleton, which extends outward into the limbs. We will take time with the skull, the spine, the rib cage, the arms, and the legs. Along the way, we will also pause to look closer at the microscopic structure of bone, at the way joints move, and at how the skeleton changes across the stages of life. Each part of the skeleton has a role to play, and each adds to the quiet harmony of the whole. For now, let us rest with a simple thought. The skeleton, though often unseen, is always with us. It does not ask for recognition, yet it gives us shape and possibility. It supports us through every moment of our lives, whether we are in motion or at rest. As you breathe gently, imagine the bones within you, steady and calm, forming the framework that allows your life to unfold. Like the quiet beams of a house, they hold you, protect you, and remain with you, night after night, day after day. And so this is our beginning, a gentle introduction to the skeleton, a system both simple in its clarity and astonishing in its detail. In the chapters to come, we will trace its form more closely, moving through the skull, the spine, the ribs, and the limbs. But here, in this first moment, it is enough to know that within you lies a structure of quiet strength, a companion as old as life itself, and one that carries you with grace and resilience into every tomorrow. 2. What the skeleton is. When we speak of the skeleton, it is easy to imagine it as a rigid frame of bone, something separate from the living body, something fixed and unchanging. Yet the truth is gentler and far more fascinating. The skeleton is not a lifeless scaffold, but a living, breathing system woven into every moment of your existence. It provides structure, but it also adapts, nourishes, and responds. It is the quiet framework of your life, present in every movement and every breath. To understand what the skeleton is, We must begin with the simple yet profound idea that it is both support and protection, both stability and motion. It is a balance between firmness and flexibility, designed to carry you through the changing seasons of your life. The human skeleton contains just over 200 distinct bones, most often described as 206. Each bone is unique in shape, size, and function, yet none stands alone. They are bound together by ligaments, cushioned by cartilage, and given movement by muscles and tendons. Imagine the skeleton as a symphony, each instrument playing its part, some bones large and weight-bearing, like the femur, some delicate and precise, like the bones of the fingers, others broad and protective, like the ribs. Together, they create harmony, not through sameness, but through cooperation. The skeleton has several essential roles, each woven seamlessly into the fabric of life. The first is support. Without bones, the body would collapse under the pull of gravity. Soft tissues would have no framework, no stable shape to hold them. Muscles would contract without purpose. Lungs would have no protective cavity, and the heart would have no shield. Bones give the body its form, from the broad arch of the shoulders to the gentle curve of the spine. This is why skeletons of different creatures reveal so much about their nature. The tall limbs of a giraffe, the sturdy shell of a turtle, or the wings of a bird all speak to the life that flows around the bones. For humans, the skeleton gives us our upright posture, our ability to stand and walk on two legs, and our capacity to reach and grasp with our arms. A second vital role is protection. Deep within the body lie organs too fragile to withstand the world on their own. The skull cradles the brain, the vertebrae guard the spinal cord, and the rib cage shields the heart and lungs. Each protective structure is carefully shaped, not only to enclose what is vulnerable, but also to allow those organs to function. The rib cage, for instance, does not form a solid wall but a flexible series of curved bones. This design offers both strength and movement, allowing the chest to expand with every breath. The skeleton does not simply protect by enclosing. It protects by adapting, ensuring that safety and function exist together in balance. A third role is movement. Though muscles pull and contract to create motion, they can only do so because they are anchored to bones. Joints act as pivot points, ligaments hold the pieces together, and tendons transmit muscular force into action. Consider the simple act of raising an arm. The shoulder joint provides the range. The humerus gives the arm strength, and the muscles act through tendons to lift. None of this could happen without bone as a foundation. Movement, from the smallest flick of a finger to the longest stride, relies on the skeleton. Beyond these visible roles, the skeleton also carries hidden responsibilities. Within the marrow of many bones lies the birthplace of blood. Red marrow produces red blood cells to carry oxygen, white blood cells to defend against illness, and platelets to seal wounds. In this sense, bones are not only structural beams, but also life-giving chambers. They produce the very cells that circulate in your body every second, keeping you alive. Alongside this, bones serve as reservoirs of minerals, particularly calcium and phosphorus. These minerals are essential for countless processes: muscle contraction, nerve signaling, and the steady rhythm of the heart. When blood levels drop, bones release these minerals into circulation. When levels rise, bones store the excess away. The skeleton is not passive, but an active participant in maintaining balance within the body. It is also worth noting how light and graceful this framework truly is. One might expect that carrying 200 bones would weigh the body down, But the skeleton is remarkably efficient. Hollow spaces within long bones reduce weight without sacrificing strength, and the arrangement of spongy and compact tissue ensures resilience against impact. The entire adult skeleton makes up only about 1/7 of body weight, a delicate balance between lightness and durability. This is why humans can walk long distances, leap, run, and bend without being crushed by the very structure that supports them. As we think about what the skeleton is, it helps to reflect on its presence throughout life. At birth, it is soft and flexible, built from a mixture of bone and cartilage. As childhood unfolds, bones grow rapidly, lengthening and strengthening. In adolescence, the skeleton responds to surges of growth hormones, adding both height and density. In adulthood, it becomes more stable, serving its steady purpose of support and motion. Even then, bone does not sleep. Every day, bone cells quietly remove old tissue and replace it with new. By late life, the balance shifts, and bones may thin, becoming lighter and more fragile. Yet the essence remains. From the first breath to the last, the skeleton endures, adapting to the needs of the body at each stage. The skeleton is also deeply connected to identity. In fields like anthropology and archaeology, bones reveal stories long after soft tissue has faded away. They tell of age, stature, and ancestry. They record the stresses of labor, the patterns of movement, even the traces of ancient injuries. A skeleton may rest silently for centuries, yet it still carries the memory of a life once lived. This timeless quality reminds us that the skeleton is not only a structure of biology, but also a vessel of history. As we drift deeper into our exploration, let us think of the skeleton not merely as bone, but as a friend to the body. It does not speak aloud, yet it supports your every gesture. It does not demand attention, yet it shields your most vital organs. It carries weight, it allows motion, and it quietly makes possible the miracle of life. It is not separate from you, it is you, just as much as your heartbeat, your breath, or your thoughts. And so, when we ask, what is the skeleton? The answer unfolds gently. It is the framework of your life, the silent architecture that gives you form. It is a living structure, constantly changing, endlessly supporting. It is strength and softness joined together. It is the quiet companion that allows you to stand tall, to move freely, and to rest deeply. It is always with you, carrying you through every moment. 3. The living nature of bone. When people think of bones, they often imagine something hard, pale, and unchanging, like the dry fragments displayed in museums or uncovered from the earth. Yet the reality of living bone within your body is something far more remarkable. Bone is not a lifeless material. It is alive. It breathes in its own way. It repairs itself. It grows, and it renews. It is a dynamic tissue, filled with cells, fibers, minerals, and blood vessels, all working together in quiet harmony. To think of bone as living is to shift the way we see the skeleton, not as a stiff and silent cage, but as a vibrant and responsive system that shapes itself to the needs of the body. At the heart of bone's living nature are its cells. 3 primary kinds of bone cells keep this constant rhythm of life moving forward. Osteoblasts are the builders. They form new bone tissue, secreting proteins like collagen that serve as a soft framework, later hardened by minerals such as calcium and phosphorus. Osteoclasts, by contrast, are the recyclers. They break down old bone, dissolving its minerals, so they can be reused or released back into the bloodstream. Between these two forces are osteocytes, the guardians. These are mature bone cells that rest quietly within the bone, sensing the stresses placed upon it and sending signals to either build more or remove what is no longer needed. Together, these three types of cells form a cycle: construction, preservation, and renewal that continues without pause throughout life. Bone itself is a blend of organic and inorganic materials. The organic part, made largely of collagen, gives it flexibility and resilience. The inorganic part, composed mainly of calcium phosphate, gives it strength and rigidity. This union of softness and hardness is what makes bone so unique. Too much mineral, and it would be brittle, shattering under stress. Too much collagen, and it would be soft and unable to bear weight. But in perfect proportion, these elements create a tissue that is both strong and slightly elastic, able to endure the pressures of daily life. When you walk, your bones absorb impact. When you bend, they flex ever so slightly. When you fall, they resist breaking, unless the force is overwhelming. It is this balance that allows humans to move with both strength and grace. Inside the structure of bone lies another layer of wonder. If one could look closer, down into the microscopic arrangement, you would find repeating units known as osteons. These are cylindrical structures arranged like the rings of a tree, each surrounding a central canal filled with blood vessels and nerves. This design is not random. It ensures that bone remains nourished, with blood flowing through even its densest regions. Tiny channels, called canaliculi, connect bone cells to one another, allowing them to share nutrients and signals. In this way, the skeleton is not only alive, but connected a community of cells working together, each part aware of the whole. In certain regions of bone, the architecture shifts toward the center of long bones. Beneath the dense outer layer known as compact bone lies spongy bone. Despite its name, it is not soft, but structured with a lattice of delicate struts called trabeculae. This arrangement makes bone lighter without sacrificing strength, much like the framework of a bridge. It also creates spaces that hold bone marrow, the soft tissue that produces blood cells. Red marrow, active in children and still present in certain adult bones, is where new red blood cells, white blood cells, and platelets are constantly made. Yellow marrow, more common in adults, stores fat but can convert back to red marrow if the body ever requires more blood production. Thus, the interior of bone is not empty, but alive with activity, sustaining the blood that sustains life itself. One of the most extraordinary qualities of bone is its ability to heal. Unlike many other tissues, bone can repair itself fully after injury. When a fracture occurs, the body quickly sets in motion a process of repair. At first, a soft callus of collagen and cartilage forms around the break, stabilizing the pieces. Then osteoblasts arrive, laying down new bone material, gradually replacing the callus with solid bone. Over weeks and months, this new bone is reshaped and strengthened, often becoming as strong, or even stronger, than before. This ability to restore itself reflects the living, adaptable nature of bone. It is not static, but constantly renewing, able to mend and strengthen in response to life's challenges. Bones are also sensitive to the demands placed upon them. When you exercise, especially in ways that stress the skeleton, such as walking, running, or lifting, your bones respond by building more density. Osteocytes, those quiet guardians, sense the increased load and signal for more bone to be laid down, making the skeleton stronger. Conversely, when bones are not used during long periods of rest or immobility, they can lose density, becoming lighter and more fragile. It grows stronger when strength is required, and it lightens when demand is reduced. The living nature of bone is, in this sense, a story of balance. Beyond their role in structure and repair, bones also serve as silent regulators of the body's chemistry. They act as vast storage sites for calcium and phosphorus, minerals vital for nerve transmission, muscle contraction, and countless cellular processes. When blood levels of calcium dip too low, the skeleton releases some of its stores, guided by hormonal signals. When levels rise too high, it reabsorbs the excess. This exchange happens continuously, unnoticed, as the skeleton works quietly to maintain balance within the body. Without this role, critical functions like the heartbeat and the firing of nerves could not remain steady. It is striking to realize that within every bone, life flows in hidden channels. Nutrients enter, cells communicate, blood is created, minerals are exchanged, and tissue is constantly remade. To hold a bone in one's hand, dry and silent, is to see only the shadow of what it once was. Within the living body, bone is vibrant, endlessly active, always aware of the forces around it. It is not only structure but also process, a continuous story of building, sensing, and responding. As we reflect on this, it becomes clear why the skeleton is not merely a framework of support, but a living organ system in its own right. Each bone is an organ, made of tissue, cells, and vessels, all working together. The skeleton as a whole is a network, alive and dynamic. It may be hidden beneath skin and muscle, but it is never dormant. It listens, it adapts, and it sustains. And so, when we consider the living nature of bone, we find ourselves seeing the skeleton anew. It is not simply what holds us up, nor only what gives us shape. It is alive with quiet activity, alive with balance, alive with renewal. In every moment of your life, it is there, building, repairing, supporting, and providing. To know this is to carry a deeper appreciation of the body not as a machine, but as a living harmony, with the skeleton as one of its most essential songs. 4. Bone growth and remodeling. The story of bone is not only about its living nature, but also about its ability to grow, to change, and to renew itself across the entire span of life. From the fragile beginnings of infancy to the strength of adulthood, and eventually into the gentler stages of later years, bones are never fixed. They are always in motion, though the motion is not something we see with the eye. It is a quiet rhythm, unfolding deep within the body, where cells are constantly breaking down old bone and laying down new. This process, known as bone growth and remodeling, is one of the great marvels of the human body, and it is what allows the skeleton to adapt, to heal, and to endure. In the earliest stage of life, the skeleton is not entirely made of bone. In the womb and in the first months of infancy, much of it begins as cartilage, soft, pliable tissue that bends easily and provides flexibility. This is why infants can move with such suppleness, why their skull bones are not yet fused, and why the body of a newborn seems more fluid than firm. As growth unfolds, a process called ossification begins. Tiny centers within the cartilage begin to harden as minerals, especially calcium and phosphate, are deposited. Gradually, cartilage is replaced with bone tissue, and the skeleton takes on the strength it needs to support a growing child. This growth continues throughout childhood, as bones lengthen at specialized regions known as growth plates. These plates, found near the ends of long bones, are areas of actively dividing cartilage. As the cells multiply, the bone lengthens, stretching the body taller year by year. This is why children grow so rapidly, sometimes seeming to change height almost overnight. Within the growth plates, new cartilage is constantly formed and then transformed into bone, a cycle that continues until late adolescence. At that time, the growth plates gradually close, fusing into solid bone, and the skeleton reaches its final adult height. Even after bones have reached their adult size, they remain far from finished. Throughout life, bones are constantly renewed through the process of remodeling. Imagine a home that is always being repaired, old beams replaced with new, worn parts removed and rebuilt. This is what happens in your skeleton, though silently and without interruption. Specialized cells called osteoclasts resorb bone, breaking down its old or damaged tissue. At the same time, osteoblasts follow behind, laying down fresh bone material in its place. The balance between these two activities ensures that bones stay strong, resilient, and responsive to the body's needs. Remodeling has many purposes. One is repair. When bones are injured, such as in a fracture, the body responds with remarkable efficiency. At first, a clot forms at the site, creating a foundation for healing. Then cells begin to form a soft callus of cartilage and fibers, stabilizing the break. Over time, osteoblasts replace this with new bone, and the area hardens. Finally, the bone is reshaped, smoothing and strengthening until the repair is complete. Unlike many tissues in the body, bone can heal without leaving scar tissue, restoring itself to full function. This ability is one of its most remarkable gifts. Remodeling also allows bones to adapt to the stresses placed upon them. The skeleton is not rigid, but responsive. When you place weight on your bones through walking, running, or lifting, tiny signals within the bone sense the stress. Osteocytes, the watchful cells embedded deep within, respond by calling for more bone to be built, increasing density and strength. Over time, this makes bones more resistant to fracture and better able to support the body. On the other hand, when bones are not used during periods of bed rest, immobility, or reduced activity, they lose density. Without the regular stress of weight bearing, bones gradually become lighter and more fragile. This is why movement, even gentle walking, is so important for maintaining skeletal health. Hormones also play a central role in growth and remodeling. During childhood and adolescence, growth hormone and sex hormones, like estrogen and testosterone, guide the rapid elongation of bones. In adulthood, hormones such as parathyroid hormone and calcitonin help regulate the balance between building and resorption, ensuring calcium levels in the blood remain steady. Estrogen, in particular, helps protect bone density, which is why bones may thin after menopause, when estrogen levels naturally decline. This hormonal influence reminds us that bone is not isolated, but interconnected with the wider systems of the body, always adjusting to the signals it receives. Nutrition, too, is vital. Calcium, drawn from food, is the primary mineral deposited in bone, giving it strength. Vitamin D ensures that calcium is absorbed from the digestive tract into the bloodstream, where it can be used to build bone tissue. Without adequate calcium and vitamin D, bones may become weak and brittle. Protein, magnesium, and other nutrients also play a supporting role. Thus, the food we eat quietly nourishes the skeleton, feeding the cycle of growth and renewal. Remodeling also reflects the passage of time. In youth, Bone building exceeds bone breakdown, allowing the skeleton to grow and strengthen. In early adulthood, the balance reaches its peak, and bones are at their strongest. As the years pass, however, resorption begins to outpace formation, and bones gradually lose density. This does not mean they cease to function, but simply that the rhythm shifts, and the skeleton grows lighter. With care through nourishment, movement, and balance, bones can remain resilient well into later years, carrying the body through a long and active life. It is humbling to realize how much is happening beneath the surface at every moment. While you go about your day, millions of microscopic sites of remodeling are active within your skeleton. Some regions are being broken down, while others are being rebuilt. It is a continuous cycle, invisible but essential, allowing bones to respond to every challenge placed upon them. A skeleton is never old in the way we might imagine. Even in later life, parts of it are new, freshly laid down by osteoblasts only days or weeks before. When we look at the whole picture, bone growth and remodeling tell a story of balance, from the softness of infancy to the strength of youth, from the steady resilience of adulthood to the gentler framework of later years. The skeleton is always adapting. It bends but does not break. It weakens but does not surrender, and it heals in ways that remind us of the body's deep capacity for renewal. As you rest, consider the quiet work happening within you right now. Bones sensing the weight of your body, cells breaking down old tissue, other cells laying down the new. Even in sleep, the cycle continues, endlessly repeating, silently keeping you whole. The skeleton is not a relic, but a living companion, one that grows, changes, and remakes itself with you, always. 5. The skeleton as a whole. When we step back from the details of bone cells and the quiet rhythms of remodeling, it becomes soothing to view the skeleton not in fragments, but as a whole. The human skeleton, in its entirety, is a marvel of design, a framework that balances strength with lightness, protection with movement, and endurance with flexibility. It is, in many ways, the silent architecture of the body, a structure both sturdy and graceful, carrying us through every moment of our lives. To understand the skeleton as a whole is to see how each part, each bone, joins with the others to form a living system of unity. The skeleton is most often described as being divided into two great regions, the axial skeleton and the appendicular skeleton. These are not separate entities, but rather two halves of one design, complementing and balancing each other. The axial skeleton, forming the central core, includes the skull, the vertebral column. Its purpose is stability and protection, guarding the most vital organs of life, the brain, the heart, and the lungs. The appendicular skeleton, extending outward, includes the bones of the arms, legs, shoulders, and hips. Its purpose is motion, interaction with the world, and balance. Together, these two regions create a body that is both steady and mobile, both grounded and free. If we begin with the axial skeleton, we see a framework that forms the central pillar of the body. The skull, with its many bones carefully joined together, houses the brain and provides shape to the face. The vertebral column, made of individual vertebrae stacked in alignment, protects the spinal cord while allowing flexibility and movement. The rib cage, with its curved bones and central sternum, forms a protective enclosure for the lungs and heart, expanding gently with each breath. This axial core is the foundation of the body, the structure that ensures safety for the organs that sustain life. The appendicular skeleton, by contrast, is an expression of mobility and grace. From the shoulder girdle, with its delicate balance of the clavicle and scapula, extend the arms, capable of both strength and precision. The humerus, radius, and ulna form the bones of the upper limb, joined to the intricate network of the wrist and hand. These allow humans not only to lift and carry, but also to grasp, to write, to hold. The lower limbs, beginning with the pelvis, provide stability and support for walking, running, and standing upright. The femur, tibia, fibula, and the many bones of the foot form a system of strength that carries the weight of the body, while also allowing the grace of movement. Without this combination of steadiness and motion, life as we know it would not be possible. Another way of appreciating the skeleton as a whole is to notice how its many parts are shaped for specific roles, yet always in harmony with the larger design. Long bones, such as the femur and humerus, act as levers, amplifying the force of muscle contraction and allowing movement across distance. Flat bones, like the skull and sternum, provide broad surfaces for protection and attachment. Short bones, such as those in the wrist and ankle, allow for fine adjustments and subtle movements. Irregular bones, like the vertebrae, carry out unique functions that could not be achieved by more simple shapes. Each bone is different, yet each contributes to the unity of the skeleton. This unity is further revealed in the joints, where bones meet and interact. Some joints, like those in the skull, are fixed, designed only for strength and protection. Others, like the joints of the spine, allow limited movement, creating flexibility without weakness. Still others, like the shoulders and hips, are freely movable, designed for a wide range of motion. Through these joints, the skeleton becomes more than a rigid frame. It becomes a living, moving system, capable of both stability and fluidity. The whole skeleton is also designed for balance. It is not by chance that the body can stand upright on two legs, that it can bend without toppling, and that it can move with agility. The distribution of weight, the curves of the spine, the arrangement of the pelvis, and the length of the limbs are all part of this balance. The skeleton has evolved not only to endure the pull of gravity, but to use it, to create a posture that is both strong and efficient. This balance is so natural that we rarely think about it, yet it is a profound achievement of the skeletal design. When seen as a whole, the skeleton is also a testament to endurance. Bones are constantly renewed, but the framework itself persists throughout life. The skull that forms in infancy is the same skull that protects in old age, though remodeled and reshaped by time. The spine bends with us as children, carries us through adulthood, and supports us in later years. The legs walk countless miles, the arms lift, reach, and create. This continuity reminds us that the skeleton is not only a structure, but a lifelong companion, one that grows and changes with us. There is also beauty in the symmetry of the skeleton. Left and right, paired bones mirror one another, creating balance and proportion. The arms reflect the legs in structure, though adapted for different purposes. The spine divides the body into two halves, uniting them through its central role. Even within this symmetry, there is variation, subtle differences that make each skeleton unique. This is why bones can reveal individuality, why no two skeletons are entirely alike, though they share the same design. The skeleton as a whole is both simple and complex. Simple in that it can be divided into a central core and extending limbs into bones of protection and bones of motion. Complex in the way each part interacts with every other, creating a system that is both unified and adaptable. It is an architecture that has evolved over millions of years, refined by the demands of movement, survival, and balance. To look at the skeleton in its entirety is to see not only the structure of the human body, but also the story of human life itself. As you rest and reflect, you might imagine the skeleton as a great cathedral within you, its pillars and arches supporting all that you are. Each bone is a stone in that cathedral, shaped and placed with purpose, forming a whole that is greater than the sum of its parts. It does not demand your attention, yet it is always there, bearing your weight, shielding your organs, and allowing you to move through the world. In this sense, the skeleton as a whole is not only biology, but also quiet poetry, a structure of life that is both enduring and graceful. And so, when we think of the skeleton in its entirety, we see more than a collection of bones. We see a living system, balanced and harmonious, carrying us through life. It is central and extending, strong and light, protective and free. It is a whole, and within that whole, it sustains the very essence of being human. 6. The axial skeleton. The human skeleton, when divided into its great regions, begins with what is called the axial skeleton. This is the central framework of the body, the steady pillar around which everything else is arranged. It is the axis, the line of stability that runs from the crown of the head down through the spine to the base of the body. Unlike the appendicular skeleton, which extends outward into arms and legs, the axial skeleton stays close to the center, serving as protection, support, and balance. It holds the most essential organs of life, shields the nervous system, and provides the foundation for posture. The axial skeleton is composed of 3 major parts: the skull, the vertebral column, and the thoracic cage. Together, they form a structure of remarkable resilience. The skull, at the very top, encloses and protects the brain. The vertebral column, stretching downward, serves as both a shield for the spinal cord and a flexible column of support. The thoracic cage, made of ribs and sternum, protects the heart and lungs while expanding and contracting with each breath. These 3 elements work together as the protective shell of the human body, ensuring that the most delicate and vital organs are safeguarded within. The skull is perhaps the most striking feature of the axial skeleton. It is a structure made up of many bones fused together, forming a hard case for the brain, while also creating the foundation for the face. The cranium, the part that surrounds the brain, is smooth and rounded, designed to protect against injury. The facial bones, meanwhile, form the jaw, the cheekbones, the nasal structures, and the sockets that hold the eyes. Every contour has meaning, the jaw allowing speech and chewing, the nasal bones shaping the airway, the orbit providing protection for the delicate eyes. Though it may seem a rigid structure, the skull has points of flexibility during early life. In newborns, the bones of the skull are not yet fused, leaving soft regions called fontanelles that allow the head to compress during birth and to expand as the brain grows. Over time, these gaps close, forming the solid shield that remains throughout adulthood. Beneath the skull runs the vertebral column, sometimes called the spine. This is not a single bone, but a series of vertebrae stacked in alignment, one upon another. In adults, the column contains 33 vertebrae, though some are fused in certain regions. These vertebrae are divided into 5 sections: the cervical, thoracic, lumbar, sacral, and coccygeal regions. The cervical vertebrae, 7 in number, form the neck and support the head. The thoracic vertebrae, 12 in total, connect to the ribs, shaping the upper back. 5 in number carry the greatest weight, supporting the lower back. Below these, the sacrum and coccyx form fused structures at the base, stabilizing the pelvis. Together, these regions create a column that is both strong and flexible, able to bend, twist, and carry weight while protecting the spinal cord within. The spinal cord itself is a delicate structure of nerves, the main communication pathway between brain and body. The vertebrae encase it within a central canal, shielding it from harm. Small openings between vertebrae allow spinal nerves to branch outward, carrying signals to the rest of the body. Without the vertebral column's protection, the nervous system would be too vulnerable to survive the demands of daily life. The spine is therefore more than a column of support, it is a guardian of communication, preserving the link between thought and action. The shape of the vertebral column is also important. It is not a rigid rod, but rather curved in a gentle shape. The cervical and lumbar regions curve inward, while the thoracic and sacral regions curve outward. This arrangement distributes weight evenly, allowing the body to remain upright with efficiency. The curves act as springs, absorbing shocks from walking and movement. They make it possible to stand, to balance, and to move with grace. In this way, the spine is not only strong but adaptable, carrying the body with quiet resilience. Encircling the chest is the thoracic cage, formed by the ribs and the sternum. This structure surrounds the heart and lungs, creating a protective enclosure, while still allowing the chest to expand and contract with each breath. The ribs, 24 in total, are arranged in pairs, curving outward from the spine to the front of the chest. The upper ribs attach directly to the sternum, while the lower ribs have more flexible connections, allowing freedom of movement. The lowest two pairs, called floating ribs, do not connect to the sternum at all, but still provide protection at the sides. The sternum itself lies at the center of the chest, a flat bone where many ribs meet. Together, these elements form a cage that is both protective and dynamic, guarding the organs within while moving gently with each inhale and exhale. The thoracic cage also has another purpose. It provides the anchor points for muscles of respiration. When you breathe in, the diaphragm contracts downward, and the intercostal muscles between the ribs lift them upward. This expansion enlarges the thoracic cavity, drawing air into the lungs. When you breathe out, the process reverses. In this way, the ribs and sternum are not passive shields, but active participants in breathing. They shape the rhythm of respiration, expanding and contracting in harmony with the needs of the body. When seen together, the skull, vertebral column, and thoracic cage form a unified whole, the axial skeleton. This central framework gives shape to the body, protects the brain and internal organs, and provides the foundation for movement. Without it, the body could not survive, let alone thrive. The axial skeleton is the core upon which all else depends, the steady axis around which the limbs move and the body interacts with the world. It is worth pausing to appreciate the harmony of design in this system. The skull, solid and protective, rests atop the flexible vertebral column, which in turn supports the rib cage. Each part has its role, and together they form a structure that balances protection and mobility. This balance is not accidental but essential, the result of countless generations of refinement through time. The axial skeleton is not only a biological necessity, but also a quiet masterpiece of structure, a central pillar that holds the body upright, safe, and steady. As you reflect on the axial skeleton, you might imagine it as a calm tree trunk, rooted and strong, supporting the branches that extend outward. The skull is the crown, the spine, the trunk, and the rib cage, the sheltering branches that protect what lies within. This central structure is always with you, steady and silent, carrying you through the movements of the day and the stillness of the night. 7. The skull. Overview. At the very top of the axial skeleton rests the skull, a structure both strong and intricate, protective yet expressive. It is the crown of the human framework, a collection of bones fused together in harmony, forming a shield for the brain, while shaping the face through which we interact with the world. To look at the skull as a whole is to see both function and artistry. It is not only a vault for the most delicate organ of thought, but also the foundation of the senses: vision, smell, taste, and hearing, each housed within its contours. The skull is therefore more than bone. It is the architecture of awareness, the structure that allows human beings to see, to speak, and to experience life. The skull is composed of two major regions: the cranium and the facial bones. The cranium is the protective case for the brain, enclosing it from all sides. It is rounded, smooth, and strong, designed to withstand impacts while keeping the brain safe within. The facial bones, by contrast, are arranged in a way that creates the unique features of every human face. They form the eye sockets, the nasal cavity, the jaw, and the cheeks. Together, the cranium and facial bones merge into a single unit, joined by sutures, fibrous joints that lock the bones together with remarkable strength. These sutures appear as fine seams upon the skull, silent reminders that what appears as one structure is in fact many, joined perfectly into a whole. The cranium itself is made of 8 bones, each with its own role. The frontal bone, forming the forehead, also shapes the upper edge of the eye sockets. Behind it are the parietal bones, a pair that form much of the top and sides of the skull. At the very back lies the occipital bone, which curves downward to form the base of the skull, with an opening called the foramen magnum, where the spinal cord passes through to join the brain. Along the sides are the temporal bones, housing the structures of hearing and balance, as well as forming part of the jaw joint. Between them rests the sphenoid bone, a keystone in the center of the skull, anchoring many others. Finally, the ethmoid bone lies near the nasal cavity, delicate and light, helping to form the walls of the orbits and passages for the sense of smell. Together, these 8 bones create a rounded case, strong yet lightweight, enclosing the brain in safety. The facial bones, numbering 14, bring structure and expression to the human face. The maxilla forms the upper jaw and part of the hard palate, anchoring the upper teeth and shaping the midface. The mandible, the lower jaw, is the only movable bone of the skull, allowing speech and chewing. The zygomatic bones form the cheekbones, giving the face its contours. The nasal bones shape the bridge of the nose, while the lacrimal bones, small and delicate, form part of the tear ducts. The palatine bones, inferior nasal conchae, and vomer contribute to the structure of the nasal cavity and palate. These bones, though small compared to the cranium, carry immense importance, for they create the foundation of sight, smell, taste, and communication. The skull is also home to the orbits, the deep sockets that cradle the eyes. Each orbit is not a single bone, but a composite structure formed by parts of several bones: frontal, sphenoid, zygomatic, maxilla, ethmoid, lacrimal, and palatine. Within these spaces, the eyes are held securely, cushioned by fat and muscles that allow their movement. The orbits are like windows of the skeleton, open to the world, protected yet receptive. Through them, light enters and vision begins, carried inward by nerves that pass through small openings in the bone. Another remarkable feature of the skull is the number of foramina, small holes and passages that allow nerves and blood vessels to travel through the bone. These openings are gateways, linking the brain with the rest of the body. The optic canal allows the optic nerve to carry vision to the brain. The jugular foramen permits veins to drain blood from the head. The foramen ovale, rotundum, and spinosum allow the passage of critical nerves and vessels. Though they are only small gaps in the hard surface of bone, they are vital pathways, ensuring that the brain within is connected to the world without. One of the most significant aspects of the skull is its role in expression and identity. While the cranium is broadly similar across all humans, the facial bones vary in ways that create individuality. The curve of the jaw, the height of the cheekbones, the width of the nasal opening, all combine to form the uniqueness of every human face. The skull is therefore not only protective but also personal, shaping the outward appearance through which humans recognize one another. Beneath skin and muscle, this bony architecture carries the features that make each person distinct. In infancy, the skull holds another wonder. At birth, the bones of the cranium are not yet fused, leaving soft regions called fontanelles. These spaces allow the skull to compress during childbirth and expand as the brain grows. The most prominent, the anterior fontanelle, can be felt at the top of a baby's head, a soft, pulsating space where the heartbeat may be seen. Over time, these regions close, the bones fusing together to create the solid skull of adulthood. This flexibility in early life is a reminder of how living and adaptable bone truly is. The skull also has a role in sound and resonance. Hollow spaces within some bones, known as paranasal sinuses, lighten the weight of the skull while also serving as chambers that affect the tone of the voice. These sinuses, frontal, maxillary, sphenoid, and ethmoid, are lined with mucous membranes and connected to the nasal cavity. Their presence makes the skull lighter, their function subtle yet important. When speaking, singing, or breathing, these hollow chambers contribute quietly, shaping the resonance of sound. Seen as a whole, the skull is both fortress and foundation. It is a fortress for the brain, enclosing it in bone that resists injury and shields it from harm. It is a foundation for the senses, providing the structure for eyes, ears, nose, and mouth. It is a framework for individuality, shaping the features of every human face. It is also a passageway, with openings that connect the inner world of the brain to the outer world of sensation and action. Every contour, every seam, every opening has purpose. As you reflect upon the skull, it is calming to imagine it not only as a structure of strength, but also as a vessel of experience. Within its protection lies the organ of thought, memory, and consciousness. Upon its features rests the expression of identity. Through its openings flow the signals that allow perception and action. The skull, silent and unseen, makes all of this possible. It is more than bone. It is the architecture of life's awareness. 8. The skull, facial bones. When we turn our attention from the protective dome of the cranium to the front of the skull, we arrive at the facial bones, the framework that gives shape to the human face. These bones, though smaller and more delicate than those of the cranium, carry extraordinary importance. They not only support the senses of sight, smell, and taste, but also create the contours of expression and individuality. Within their structure lies both utility and identity. The ability to eat, breathe, and speak, as well as the features that make every face unique. The facial skeleton is composed of 14 bones, carefully arranged and joined by sutures. Unlike the rigid vault of the cranium, these bones are varied in size and function, forming the jaw, the cheeks, the nasal passages, and the sockets for the eyes. They work together not only as a protective frame but also as a foundation for movement. For the mandible among them is the only movable bone of the skull. This mobility allows speech and chewing, actions so central to human life that they define daily existence. The facial bones therefore embody both quiet stability and graceful motion. The largest of the facial bones is the mandible, the lower jaw. It forms the foundation of the mouth, housing the lower teeth and shaping the chin. Unlike most bones of the skull, it does not remain fixed, but instead moves at its joints with the temporal bones, forming what is known as the temporomandibular joint. This joint is unique, combining hinge-like movement with the ability to slide forward and side to side. It is what allows humans to chew food with precision and to form the subtle movements needed for speech. The mandible is also one of the most distinctive features of the face, giving contour to the jawline and expression to the lower half of the visage. Above the mandible rests the maxilla, the upper jaw. This bone anchors the upper teeth, forms part of the eye sockets, and shapes much of the middle face. It also creates the hard palate, the bony roof of the mouth which separates the oral cavity from the nasal passages above. This separation is essential for speaking and breathing, allowing humans to chew food without interrupting respiration. The maxilla also contains the largest of the paranasal sinuses, hollow spaces that lighten the weight of the skull and contribute to vocal resonance. Together, the mandible and maxilla form the central framework of the mouth and jaw, enabling the acts of eating, speaking, and breathing. To either side of the maxilla are the zygomatic bones, often called the cheekbones. These bones extend outward, forming the prominence of the cheeks and contributing to the outer walls of the eye sockets. They join with the temporal bones by long, thin processes, creating the zygomatic arch, a graceful curve that can be felt along the side of the face. The zygomatic bones not only define the contours of the cheeks, but also provide attachment points for muscles used in chewing. Their shape gives strength to the face, while also contributing to its outward beauty and individuality. Moving upward, we find the nasal bones, two small rectangles that form the bridge of the nose. Though modest in size, they set the foundation for the nose's structure, supporting the cartilage that extends outward to shape the nasal profile. Beneath them lies the vomer, a thin bone forming part of the nasal septum, which divides the nasal cavity into two passages. Flanking the sides of the cavity are the inferior nasal conchae, delicate, curled bones that increase the surface area within the nose, helping to warm and filter the air we breathe. These small bones, though rarely noticed, are essential for the quiet act of respiration, shaping the pathways through which every breath passes. Near the inner corners of the eyes are the lacrimal bones, the smallest bones of the face. Each lacrimal bone contains a groove that forms part of the tear duct system, allowing tears to drain from the eyes into the nasal cavity. It is a subtle but vital connection, linking sight to the act of cleansing and protecting the eye. Though only the size of a fingernail, the lacrimal bones serve a purpose that is deeply felt in moments of both protection and emotion. Deeper within the face lie the palatine bones, forming part of the hard palate at the back of the mouth, as well as parts of the nasal cavity and eye sockets. Though not outwardly visible, they contribute significantly to the architecture of the midface, supporting both breathing and speech. Their hidden presence is a reminder that not all important structures are seen. Many work quietly, shaping the functions we take for granted. When seen together, the facial bones create a framework that is both strong and delicate. They are strong in their ability to anchor teeth, to withstand the forces of chewing, and to provide protection for the senses. They are delicate in their thin structures, their fine contours, and their subtle contributions to facial expression. This combination of strength and delicacy is what makes the face both resilient and expressive, able to endure the demands of daily life, while also communicating emotion and identity. It is remarkable to consider how these bones influence individuality. While the cranium is broadly similar across all people, the arrangement of the facial bones varies in small but significant ways. The angle of the jaw, the height of the cheekbones, the breadth of the nasal opening, and the curve of the palate all contribute to the uniqueness of a face. These variations carry through history, shaping ancestry, identity, and recognition. The facial skeleton is therefore not only functional but also deeply personal, holding the features that make each human distinct. In life, the facial bones are also covered with muscles that bring them into motion. The mandible moves as one chews or speaks. The zygomatic bones anchor muscles that lift the corners of the mouth into a smile. The nasal bones support the cartilage that flares gently when air is drawn in. Though the bones themselves are silent, their shape and placement allow the expression of joy, sorrow, laughter, and speech. They are the silent stage upon which the play of human expression is performed. As you reflect upon the facial bones, it is calming to imagine them not only as rigid structures, but as gentle foundations of daily life. Every word spoken, every meal taken, every breath drawn, every smile or frown, all are made possible by this framework. The mandible opens and closes, the maxilla supports, the zygomatic arches give contour, the nasal bones shape the airway, and the lacrimal bones quietly guide tears away. Though often unnoticed, they are constant companions, shaping both function and identity in every moment. In essence, the facial bones are the meeting place of biology and individuality. They protect, they support, they enable vital functions, and at the same time, they give form to the human face, the most familiar and expressive part of the body. They are both practical and poetic, bones that carry the weight of life's necessities, while also shaping the outward reflection of the self. 9. The vertebral column. Structure. Running quietly down the center of the back, from the base of the skull to the tip of the tailbone, lies the vertebral column, often called the spine. It is one of the most important features of the axial skeleton, for it provides both strength and flexibility, both support and protection. The vertebral column is not a single bone but a series of bones, known as vertebrae, stacked carefully one upon another. This arrangement gives the spine its remarkable balance, firm enough to hold the body upright, yet flexible enough to bend, twist, and move with ease. To reflect on the vertebral column is to contemplate the body's central pillar, a structure that carries weight, safeguards the spinal cord, and allows motion all at once. In total, an adult vertebral column contains 33 vertebrae, though not all remain separate throughout life. Some are fused in the sacrum and coccyx at the lower end. The vertebrae are divided into regions, each with its own shape and function. At the top are the cervical vertebrae, 7 in number, forming the neck. Beneath them are the thoracic vertebrae, 12 in total, each connected to a pair of ribs. Below these lie the lumbar vertebrae, 5 strong bones that support the lower back. Finally, at the base are the sacral vertebrae, 5 fused into the triangular sacrum, and the coccygeal vertebrae. Together, these regions create a column that is continuous yet varied, each part adapted to the needs of its place. The cervical region, closest to the head, is the most delicate, yet also the most flexible. These 7 vertebrae allow the head to nod, turn, and tilt. The very first, called the atlas, is a ring-shaped bone that supports the skull directly. Its name recalls the figure from ancient mythology who held up the heavens. And in the same way, the atlas holds up the head. Just below it lies the axis, the second cervical vertebra, which has a peg-like projection known as the dens. This structure fits into the atlas and allows the head to rotate side to side, as if shaking no. The remaining cervical vertebrae provide further flexibility, allowing the neck to move in many directions while also supporting the weight of the skull. The thoracic vertebrae, 12 in number, form the mid-back. They are larger than the cervical vertebrae and are distinguished by their connection to the ribs. Each thoracic vertebra has facets on its sides, where the heads of the ribs attach. This connection creates the thoracic cage, enclosing the heart and lungs. Though less flexible than the cervical region, the thoracic spine allows gentle rotation and bending, movements softened by the support of the rib cage. It is a region designed more for stability and protection than for wide-ranging motion. Beneath the thoracic region lies the lumbar spine, made of 5 vertebrae. These are the largest and strongest bones of the vertebral column, for they bear the greatest share of body weight. The lumbar vertebrae have broad bodies and thick processes, built for strength and stability. They allow bending forward and backward, and some lateral motion, though rotation is limited. The lower back is often where people feel strain, for it must carry the balance of the upper body while also providing flexibility for movement. Despite this burden, the lumbar spine endures with resilience, silently supporting daily life. At the base of the column lies the sacrum, formed from 5 vertebrae fused into a triangular shape. The sacrum connects the spine to the pelvic girdle, anchoring the skeleton firmly to the hips. Its broad surface provides stability, transmitting the weight of the upper body into the lower limbs. Beneath the sacrum lies the coccyx, or tailbone, a small structure of 3 to 5 fused vertebrae. Though reduced in size and function compared to ancient ancestors, the coccyx still provides attachment points for ligaments and muscles of the pelvic floor. It is a quiet reminder of the body's evolutionary history, a trace of tales carried long ago. Each vertebra, regardless of its region, shares a common design. At its center is the vertebral body, a rounded mass that bears weight. Behind it lies the vertebral arch, a ring of bone that encloses a central space known as the vertebral foramen. When stacked, these foramina align to form the vertebral canal, the passage through which the spinal cord runs. This design creates a protective tunnel of bone, safeguarding the cord from injury. From the vertebral arch extend projections of bone where muscles and ligaments attach. These processes, though small, are essential, for they allow the spine to move while remaining supported by the surrounding tissues. Between each pair of vertebrae lies a cushion known as an intervertebral disc. These discs are made of cartilage, with a tough outer ring and a softer, gel-like center. They act as shock absorbers, softening the impact of walking, running, and lifting. They also allow flexibility, permitting the vertebrae to move slightly against one another. Though small in height individually, the discs together account for about 1/4 of the spine's total length. Their presence makes the vertebral column both flexible and resilient, able to withstand the constant stresses of daily motion. The vertebral column is not straight but gently curved. In fact, it has 4 natural curves: cervical, thoracic, lumbar, and sacral. These curves give the spine an S-shaped form when viewed from the side. They are not flaws but features, distributing weight evenly and allowing the body to balance upright. The curves also act like springs, absorbing shock and reducing strain on the vertebrae. Without them, walking and standing would be jarring and inefficient. This elegant design is a quiet example of how structure and function are joined in the human body. Beyond support and movement, the vertebral column carries out its most vital role as the protector of the spinal cord. The cord is a bundle of nerves extending from the brain, carrying messages to and from the rest of the body. Without it, sensation and movement would not be possible. The vertebral column encases it within bone, shielding it from injury, while still allowing nerves to exit through small spaces between vertebrae. These openings, called intervertebral foramina, allow spinal nerves to branch outward, linking the central nervous system with every part of the body. In this way, the spine is not only a column of support but also a channel of connection, bridging the brain with the body it guides. When seen as a whole, the vertebral column is a masterpiece of balance. It is strong enough to carry the body, flexible enough to bend, protective enough to shield the spinal cord, and adaptable enough to allow motion in many directions. It is both axis and protector, both support and channel. Without it, upright posture and coordinated movement would be impossible. With it, the body finds stability and grace. As you reflect upon the vertebral column, imagine it as a quiet tree trunk within you, rising steadily from the pelvis to the skull. Each vertebra is like a ring of that tree, contributing to the strength of the whole. The curves are its natural bends, the discs its soft cushions, the canal its hidden passageway of life. This central column is always there, holding you upright, protecting your nerves, and allowing every motion, whether great or small. It is the silent pillar of the body, steady and enduring, carrying you through each day and each night. 10. The vertebral column, gentle motion. When we consider the vertebral column, it is easy to imagine it as a rigid pillar holding the body upright. Yet the truth is more subtle and far more remarkable. The spine is not a stiff column but a living structure of flexibility. It bends, twists, lengthens, and shortens with every motion of daily life. It allows you to bow your head, to turn and look over your shoulder, to bend forward to tie a shoe, or to arch backward in a stretch. This gentle capacity for motion is what makes the vertebral column so extraordinary. It carries the weight of the body while still offering freedom of movement. The ability of the spine to move lies in the arrangement of its vertebrae and the tissues that connect them. Each vertebra is joined to the next, not by fusion but by small joints, supported by intervertebral discs of cartilage. These discs, soft yet strong, allow the vertebrae to glide slightly upon one another, making bending and twisting possible. The outer ring of each disc provides stability, while the softer center acts as a cushion, absorbing shock and distributing pressure evenly. This design means that while no single vertebra moves much on its own, the small motions of many vertebrae combine into graceful flexibility. Different regions of the spine contribute to motion in different ways. In the neck, the cervical vertebrae provide the greatest range of movement. Here the head can nod forward and backward, tilt side to side, and rotate almost fully from one direction to the other. The special design of the atlas and axis vertebrae at the top allows this extraordinary mobility. Without them, the simple act of turning the head to look at the horizon or lowering the chin in rest would not be possible. The cervical spine is therefore the most agile part of the vertebral column, finely tuned to allow freedom of motion while supporting the weight of the head. The thoracic spine, by contrast, is less mobile. Its vertebrae are connected to the ribs, creating a cage that protects the heart and lungs. This connection limits flexibility, allowing only gentle rotation and bending. Yet this reduced motion serves a purpose. It provides stability to safeguard the organs within. The thoracic spine demonstrates the balance of protection and movement, reminding us that sometimes stability must outweigh flexibility. Even so, it does allow the chest to expand and contract with breathing, moving in quiet rhythm throughout the day and night. The lumbar spine, in the lower back, is designed for strength as much as motion. These vertebrae are larger and broader, carrying the weight of the upper body. They allow bending forward and backward with relative ease, as well as some side-to-side movement. Rotation, however, is limited in this region, for twisting under heavy weight would endanger the spine. The lumbar vertebrae remind us of the spine's dual role: to bear weight and to permit motion. They provide both, but always in balance. The sacrum and coccyx, fused at the base, offer little motion of their own, yet they serve as an anchor, transmitting the weight of the spine into the pelvis and the lower limbs. Their stillness provides a foundation upon which the more flexible regions above may move freely. In this way, even the immobile parts of the spine contribute to the overall harmony of motion, providing stability that allows movement elsewhere. Supporting all of this movement are the ligaments and muscles that surround the spine. Ligaments bind vertebrae together, preventing excessive motion that could cause harm. They act like quiet straps, ensuring the spine bends within safe limits. Muscles, meanwhile, attach to the processes of the vertebrae, providing both strength and fine control. Large muscles in the back allow powerful motions like lifting and arching, while smaller, deeper muscles fine-tune alignment with each movement. These muscles and ligaments, though not part of the bone itself, are essential to the spine's grace. They turn structure into motion, stability into fluidity. The curves of the spine also play a role in its movement. The natural shape, with cervical and lumbar curves inward and thoracic and sacral curves outward, distributes weight evenly. These curves act as springs, absorbing impact and allowing the spine to flex without breaking. When you walk, the curves shift slightly with each step, softening the rhythm of motion. When you sit, they balance the body. When you lie down, they align to support rest. The curves are therefore not imperfections, but quiet adaptations that make motion efficient and smooth. The vertebral column also protects motion itself. Within its canal lies the spinal cord, carrying signals between brain and body. Small openings between vertebrae allow nerves to branch outward, reaching the muscles that control motion. Every movement from turning the head to taking a step begins as a signal within the spinal cord, traveling through these nerves to muscles. The vertebral column thus not only permits motion but also guides it, protecting the delicate channels through which instructions flow. Without this protection, the freedom of movement would not be possible. It is striking to consider how much of daily life depends upon this gentle flexibility. The spine bends when you sit and stand, when you reach for an object, when you rest your head upon a pillow. It twists when you turn to greet someone, curves when you bow, and straightens when you rise tall. Even when still, it is never entirely motionless, for with every breath the thoracic spine moves softly as the ribs lift and fall. The vertebral column is always in quiet motion, always adjusting, always balancing. This balance of strength and motion is perhaps the spine's greatest gift. It is strong enough to hold the body upright against gravity, yet supple enough to bend and twist with ease. It is stable enough to protect the spinal cord, yet flexible enough to allow expression through posture and gesture. In its design, we see a harmony that reflects the larger truth of the skeleton, that structure and function, firmness and fluidity, are always joined. As you rest and reflect upon the vertebral column, Imagine it as a calm, flowing river within you. Each vertebra is like a stone in that river, shaped and placed to guide the current of movement. The curves are its bends, the discs, its soft waters, the muscles and ligaments, its banks. The river flows not with noise but with quiet steadiness, carrying you through the motions of each day, in bending and straightening, in twisting and balancing. The vertebral column is always present, always gentle, always alive with motion. 11. The rib cage and sternum. Encircling the chest like a gentle shelter is the thoracic cage, more commonly known as the rib cage. It is one of the most elegant structures of the human skeleton. At once strong and flexible, protective, yet responsive, the rib cage is not a rigid wall but a living framework that moves with every breath, rising and falling in quiet rhythm as air enters and leaves the lungs. Within its curved embrace lie the heart and lungs, the organs most essential to life. To reflect upon the rib cage is to contemplate the body's quiet shield, a cage that protects, but one that also breathes. The rib cage is formed of three main elements: the ribs, the sternum, and the thoracic vertebrae. Together, these parts create a closed, rounded framework, sturdy enough to resist impact, but supple enough to expand and contract. In an adult, there are typically 24 ribs, 12 on each side. They sweep outward from the spine, curving gently around the chest toward the front. At their ends, they join to the sternum, either directly or through cartilage, creating a flexible yet secure connection. This design ensures that the rib cage can protect what lies within, while also accommodating the constant motion of breathing. The ribs themselves are not identical, but fall into groups based on how they connect. The first 7 pairs are known as the true ribs. Each of these attaches directly to the sternum through strips of cartilage called costal cartilages. This direct connection provides strength while allowing just enough flexibility for motion. The next 3 pairs are called false ribs. They do not attach directly to the sternum, but instead connect to the cartilage of the rib above them, creating a more indirect pathway. The final 2 pairs are known as floating ribs. These do not reach the sternum at all, but end freely in the muscles of the body wall. Though smaller, they still provide protection at the sides and back of the chest. This variety, true, false, and floating, gives the rib cage both structure and adaptability. At the center of the chest lies the sternum, a flat bone to which many of the ribs are anchored. It is often called the breastbone and can be felt beneath the skin between the collarbones. The sternum itself is made of 3 parts: the manubrium at the top, the body in the middle, and the xiphoid process at the bottom. The manubrium connects with the clavicles, forming the upper framework of the chest. The body serves as the attachment for most ribs, creating the long central shield. The xiphoid process, though small and pointed, provides a final anchor point for muscles of the abdomen. Together, these 3 parts form a solid yet flexible core at the front of the thorax. The rib cage is not only about protection but also about movement. With every breath, it rises and falls, expanding outward as the lungs fill and narrowing as they empty. This motion is made possible by the flexibility of the costal cartilages and by the action of muscles between the ribs, known as intercostal muscles. These muscles contract to lift the ribs upward and outward during inhalation, enlarging the thoracic cavity and drawing air into the lungs. During exhalation, they relax, allowing the ribs to settle back into place. The rib cage is therefore not static, but a participant in the rhythm of life, moving softly in harmony with the act of breathing. Beyond breathing, the rib cage also serves as an anchor for muscles of the upper body. The ribs provide attachment points for muscles that move the shoulders, arms, and back. The sternum anchors muscles of the chest, including those that draw the arms inward. Even the floating ribs contribute, serving as points of connection for abdominal muscles. In this way, the rib cage is not only protective but also functional, supporting a wide range of motions. The protection it provides, however, remains its most essential role. The heart, beating ceaselessly, and the lungs, rising and falling with breath, are vulnerable organs. Without the rib cage, they would be exposed to injury with every motion of the body. Enclosed within its curved walls, however, they are safeguarded, cushioned by both bone and muscle. The rib cage shields without confining, protecting while still allowing the freedom of breath. This balance of protection and motion is the hallmark of its design. The shape of the rib cage also plays a role in posture and balance. Its curved form, narrowing at the top and widening toward the base, gives stability to the upper body. It helps distribute weight evenly through the spine and pelvis, allowing the body to remain upright. Its rounded shape is not accidental, but the result of countless generations of refinement, ensuring both strength and efficiency. The rib cage is therefore not only a shelter but also a pillar, part of the architecture that holds the body steady. It is also worth noting that the rib cage changes throughout life. In infancy, the ribs are more horizontal, and the thoracic cavity is smaller. As the child grows, the ribs slope downward, and the chest expands, accommodating the growth of the lungs and heart. In adulthood, the rib cage is at its fullest size, strong and resilient. With age, the cartilages may stiffen, and the motion of the rib cage becomes less pronounced, but its protective role remains. Even in later years, it continues its quiet work of sheltering and supporting. The rib cage is also linked to the rhythms of life beyond breathing. Its expansion rises gently with exertion, its motion quickens with excitement, and it slows with rest. When calm, the ribs lift and fall like the slow tide of the sea. When active, they move rapidly, matching the pace of the body's needs. They are silent, unnoticed in daily life, yet always there, shaping the invisible music of breath. As you reflect upon the rib cage and sternum, imagine them as a curved dome of quiet strength within you, each rib like an arch, each cartilage like a flexible joint, each breath a soft expansion of this living frame. The sternum rests at the center like a calm anchor, connecting the left and right sides into a single whole. Together, they form a cage that is not confining but protective, not rigid but responsive, always moving in time with your breath, always safeguarding what is most vital. 12. The appendicular skeleton. Introduction. After spending time with the axial skeleton, the skull, the vertebral column, and the rib cage, our attention now turns outward. For while the axial skeleton is the central pillar, the quiet axis of stability, there is another great division of the skeleton that carries a different role. This is the appendicular skeleton, the system of bones that extend from the core into the limbs. It is through the appendicular skeleton that we reach into the world, that we walk upon the earth, and that we grasp, hold, and move with intention. If the axial skeleton is the trunk, then the appendicular skeleton is the branching system of arms and legs, delicate yet strong, steady yet flexible, always in motion. The appendicular skeleton is larger in number than its axial counterpart. Where the axial skeleton contains 80 bones, the appendicular skeleton holds 126. These bones form the framework of the shoulders, arms, hips, and legs. They are organized into 4 main regions: the pectoral girdle, which attaches the arms, the upper limbs, which include the bones of the arms and hands, the pelvic girdle, which anchors the legs, and the lower limbs, which include the bones of the thighs, legs, and feet. Together, these four regions extend the body outward from its core, allowing it not only to stand and move, but also to act and create. The first of these regions, the pectoral girdle, is also called the shoulder girdle. It consists of the clavicles, or collarbones, and the scapulae, or shoulder blades. These bones form the connection between the arms and the axial skeleton. The clavicles run horizontally across the upper chest, slender bones that can be felt just beneath the skin. They act as struts, holding the shoulders apart and anchoring them to the sternum. The scapulae, broad and flat, rest upon the back, forming wide surfaces for the attachment of muscles. Within each scapula lies a shallow socket, the glenoid cavity, into which the head of the humerus fits. This design, shallow and open, gives the shoulder an extraordinary range of motion, though at the cost of some stability. The pectoral girdle is thus a structure of freedom. From this girdle extend the upper limbs. Each arm begins with the humerus, the long bone of the upper arm. At its upper end, it forms the ball of the shoulder joint. At its lower end, it meets the bones of the forearm at the elbow. The forearm itself contains two bones, the radius and the ulna. These bones are arranged side by side, with the radius on the thumb side and the ulna on the little finger side. They are able to rotate around one another, allowing the hand to turn palm up or palm down. This movement, called pronation and supination, is one of the many subtle abilities that give the human hand its versatility. At the end of the forearm lies the wrist, a complex structure of 8 small bones known as carpals. These bones are arranged in 2 rows, forming a flexible yet sturdy base for the hand. Beyond them are the 5 metacarpals, the bones of the palm, which extend into the digits. The fingers themselves are formed of phalanges, 3 in each finger and 2 in the thumb. In total, each hand contains 27 bones. This abundance of small bones allows for a wide range of delicate movements, from the power of a firm grip to the subtle precision of writing or playing an instrument. The hand, built upon this framework, is one of the defining features of humanity, enabling not only survival but also creativity. Opposite the shoulders lies the pelvic girdle, anchoring the lower limbs to the axial skeleton. Unlike the light and mobile pectoral girdle, the pelvis is heavy and stable. Its purpose is not to give wide freedom of motion, but to support the weight of the upper body and to transmit it into the legs. Each side of the pelvis is formed by a hip bone, or coxal bone, itself composed of 3 parts, the ilium, the ischium, and the pubis. These 3 bones fuse during development, creating a single solid structure. At the back, the hip bones join with the sacrum of the spine, locking the skeleton into a strong ring. At the front, they meet at the pubic symphysis, a joint of cartilage that adds strength while still allowing a small degree of flexibility. The pelvis also serves as a cradle, protecting organs of the abdomen and forming the basin from which the body's weight is balanced. Extending downward from the pelvis are the lower limbs. Each begins with the femur, the thigh bone, the largest and strongest bone in the human body. It fits into the deep socket of the pelvis, forming a stable joint designed for weight bearing. The femur's long shaft descends toward the knee, where it meets the tibia and fibula of the lower leg. The tibia, or shin bone, is the larger and more weight-bearing of the two, while the fibula is slender and serves mainly as a site for muscle attachment. The patella, or kneecap, rests at the front of the joint, protecting it and aiding the leverage of the thigh muscles. At the base of the leg lies the foot, a structure as complex as the hand. Each foot contains 26 bones. The 7 tarsals of the ankle form a strong base, including the talus, which meets the tibia, and the calcaneus, or heel bone, which bears the weight of standing and walking. Beyond these lie the 5 metatarsals of the arch and the 14 phalanges of the toes. The foot's arches, formed by the arrangement of these bones, act as natural springs, absorbing shock and propelling the body forward with each step. Together, the bones of the leg and foot make possible the act of bipedal walking, a defining feature of humanity. When seen as a whole, the appendicular skeleton is a system of both freedom and support. The arms, connected by the flexible shoulder girdle, allow motion that is broad and expressive. They are designed for reaching, lifting, and creating. The legs, anchored by the stable pelvic girdle, allow motion that is powerful and enduring. They are designed for standing, walking. This division of roles reflects the balance of human life: hands for interaction, feet for locomotion, arms for action, legs for endurance. The appendicular skeleton also tells the story of adaptation. In ancient ancestors, limbs evolved for swimming, crawling, climbing, and grasping. In humans, they have been refined for upright walking and for delicate manipulation. The hands and arms allow building, writing, and artistry, while the legs allow long-distance travel across varied terrain. Within the bones of the appendicular skeleton, the history of humanity's relationship with the earth is written. In daily life, the appendicular skeleton is the part most often in motion. The hand that holds a pen, the arm that lifts a child, the legs that walk across a room, all are expressions of this system. And yet, though it moves constantly, it is quiet. The bones make no sound. They join and separate, bend and straighten, with a silence that makes their presence easy to forget. Only in reflection do we notice the marvel of their design. As you rest, you might imagine the appendicular skeleton as the branching arms of a great tree. From the central trunk of the axial skeleton, the branches extend outward, reaching into space. The shoulders are the upper branches, free and light. The hips are the lower branches, thick and grounded. The limbs extend from them, strong and graceful, always ready to move, always ready to balance. In this image, the skeleton is not only a framework of support, but a living design of balance and grace. The appendicular skeleton is therefore more than a set of bones. It is the expression of movement, the architecture of action. It allows you to walk, to run, to reach, to hold, and to create. It connects you to the world, and through its quiet service, it shapes the life you live. 13. The shoulder girdle. At the meeting point between the axial skeleton and the upper limbs lies the shoulder girdle, also known as the pectoral girdle. It is a small but remarkable structure, for it provides the base from which the arms extend, granting them both stability and extraordinary freedom of movement. Unlike the pelvis, which is strong and fixed to bear the weight of the body, the shoulder girdle is light, mobile, and versatile. It allows the arms to move in almost every direction, to lift high, to reach forward, to extend sideways, and to rotate in broad arcs. This gift of mobility is central to the human form, enabling not only the practical tasks of daily life, but also the gestures of expression and the delicate motions of creativity. The shoulder girdle is made of just 2 types of bones: the clavicles, and the scapulae. Each side of the body has one clavicle and one scapula, and together they connect the arms to the sternum and spine. Though simple in number, they are profound in function, forming a framework that balances flexibility with support. Their arrangement makes the shoulders one of the most dynamic regions of the skeleton, capable of more movement than almost any other joint. The clavicles, or collarbones, are slender, shaped bones that run horizontally across the upper chest. Each connects at one end to the sternum, forming a joint at the top of the breastbone, and at the other end to the scapula, forming part of the shoulder. Because of this placement, the clavicles act like struts, holding the arms slightly away from the chest and allowing them to swing freely. They also serve as braces, transmitting forces from the arms to the axial skeleton. If you press gently along the top of your chest, you can feel the clavicles just beneath the skin, firm yet light. Their curved shape provides strength, while their position adds elegance to the framework of the shoulders. Behind the clavicles lie the scapulae, or shoulder blades. These broad, flat bones rest against the back of the rib cage, triangular in shape, with wide surfaces for muscle attachment. The scapula is remarkable not only for its size, but also for its mobility. Unlike many bones, it does not join directly to the axial skeleton at the back. Instead, it glides freely over the ribs, held in place by muscles. This freedom allows the scapula to move upward, downward, forward, and backward, adjusting constantly to position the arm. In doing so, it extends the range of the shoulder joint, contributing to the extraordinary flexibility of the arms. Each scapula also contains several notable landmarks. At its upper corner lies the glenoid cavity, a shallow socket into which the head of the humerus fits, forming the shoulder joint. This socket is relatively flat compared to the deep socket of the hip joint, which is why the shoulder allows such wide motion. The trade-off, however, is less stability, making the shoulder more prone to dislocation. Surrounding the glenoid are projections of bone, the acromion, and the coracoid process, which serve as attachment points for muscles and ligaments. These structures act as levers and anchors, turning the scapula into a hub of muscular action. Together, the clavicle and scapula create a girdle that is not rigid but dynamic. The clavicle provides a firm brace, anchoring the arm to the sternum, while the scapula floats with freedom, guided by muscle. This combination makes the shoulder uniquely versatile. It is a region where bones and muscles work in harmony, where structure is shaped not only for strength, but for motion. Through this design, the human arm gains its extraordinary ability to move in a wide circle, to rotate fully, and to reach across space in ways unmatched by most other creatures. The importance of the shoulder girdle becomes clear when we consider its role in daily life. Every time you reach overhead to place something on a shelf, the clavicles and scapulae shift in harmony, positioning the humerus for upward motion. When you push open a door, the girdle stabilizes the shoulder joint, allowing the arm to extend with strength. When you lift your arm to wave or to embrace, the scapula rotates and tilts, expanding the reach of the limb. Even when at rest, the girdle holds the arms in balance, allowing them to hang freely at the sides without strain. The shoulder girdle also provides attachment points for many powerful muscles. The trapezius, deltoid, and pectoral muscles connect here, shaping the shoulders and upper back. These muscles not only move the arms, but also stabilize the girdle, keeping it aligned and responsive. The interplay between bone and muscle in this region is delicate, ensuring that the freedom of motion does not come at the cost of control. The clavicles and scapulae serve as the silent anchors for this activity, steady bones beneath the surface of muscle and skin. There is also a beauty in the symmetry of the shoulder girdle. Each side mirrors the other, balanced across the sternum. The clavicles arch gently outward, while the scapulae rest like quiet wings upon the back. Together, they form a frame that is both strong and graceful. This symmetry is not merely aesthetic but functional, distributing weight evenly and ensuring that motion on one side can be balanced by motion on the other. The girdle is therefore a design of harmony, uniting strength, mobility, and balance into one. The shoulder girdle, like all parts of the skeleton, changes through life. In childhood, the bones are softer, more flexible, still developing their full strength. In adulthood, they carry the demands of daily labor and motion, adapting to the stresses placed upon them. In later years, they may lose some of their resilience, yet their essential role remains. Through every stage, they continue their quiet work of supporting and guiding the arms, enabling the actions of life. When seen in the larger context of the appendicular skeleton, the shoulder girdle is the gateway of the upper limbs. It is the bridge between the stability of the axial skeleton and the mobility of the arms. Without it, the humerus would have no anchor, the arms no base of support. With it, the arms gain freedom, extending the body outward with strength and precision. As you reflect on the shoulder girdle, imagine it as a gentle hinge between the body and the world. The clavicles are like slender beams, extending across the chest. The scapulae are like quiet sails, gliding over the back, shifting with each motion of the arms. Together, they form a dynamic cradle, a structure of balance and grace. Through them, the arms move outward, expressing both action and emotion, carrying the self into the world. In this way, the shoulder girdle is more than two bones. It is the foundation of reach, the anchor of motion, the framework that makes the gestures of life possible. Every movement of the hand begins here, every embrace, every lift, every wave. It is the quiet root of expression, shaping the way the human form interacts with its surroundings. 14. The upper limb. From the broad, supportive base of the shoulder girdle, extend the upper limbs, the arms and hand structures that embody both strength and subtlety. If the legs are built for power, endurance, and carrying the body across distance, the arms are built for expression, dexterity, and fine control. The upper limb is a marvel of balance. Long bones that provide leverage for lifting, small bones that create delicate precision. Through the upper limbs, humans perform some of their most essential acts, lifting and carrying, but also writing, creating, embracing. Each upper limb is divided into three main regions: the arm, the forearm, and the hand. The arm, strictly speaking, refers to the region between the shoulder and the elbow, dominated by a single, long bone, the humerus. The forearm lies between the elbow and the wrist, containing two parallel bones, the radius and the ulna. The hand, at the end, is a complex structure of carpals, metacarpals, and phalanges, forming the wrist, palm, and fingers. Together, these bones create a system of motion and control unmatched by most other creatures. The humerus is the longest and strongest bone of the upper limb. At its upper end, it forms the ball of the shoulder joint, fitting into the shallow glenoid cavity of the scapula. This joint, known as the glenohumeral joint, is one of the most flexible in the human body. Because the socket is shallow, the humerus can move in almost every direction forward, backward, sideways, and in full circles. The trade-off for this freedom is a lack of stability, which is why the shoulder is more vulnerable to dislocation than the hip. Still, this design provides the arm with its extraordinary range, allowing it to reach across space with ease. Along the shaft of the humerus, powerful muscles attach, shaping the bulk of the upper arm. At its lower end, the humerus forms the elbow joint with the radius and ulna. Here, its rounded structures, the trochlea and capitulum, meet the bones of the forearm, creating a hinge that allows flexion and extension, bending and straightening the arm. The humerus thus serves as both lever and anchor, transmitting the forces of muscle into motion. The forearm contains two bones, the radius and the ulna, which lie side by side. The ulna, on the inner side of the arm, forms the primary hinge of the elbow. Its upper end has a curved notch, the olecranon, which fits around the humerus and creates the point of the elbow. The radius, on the outer side of the arm, is more mobile. At the elbow, it can rotate against the ulna, allowing the forearm to twist. This rotation, known as pronation and supination, turns the hand palm up or palm down. It is a simple motion, yet one that defines human dexterity. The ability to hold a bowl upright, then turn it to pour, or to rotate a tool with precision. Together, the radius and ulna give the forearm its adaptability, combining stability with rotation. At the end of the forearm lies the wrist, formed by 8 small bones known as the carpals. These bones are arranged in 2 rows, creating a flexible base for the hand. Their arrangement allows the wrist to bend, extend, and shift side to side. Though small, the carpals are vital, for they transmit forces between the forearm and the hand, while also providing the flexibility that makes the hand so versatile. Beyond the carpals are the metacarpals, 5 bones that form the framework of the palm. They extend outward from the wrist, 1 for each digit, curving slightly to shape the hand. At their ends, they meet the phalanges, the bones of the fingers. Each finger contains 3 phalanges, proximal, middle, and distal, while the thumb has only 2. These slender bones allow fine, precise motion. Joints between them permit bending, extending, and grasping, creating the ability to hold objects of many shapes and sizes. In total, each hand contains 27 bones. This abundance of small bones is what gives the human hand its unparalleled versatility. The hand can close into a strong fist, capable of lifting and carrying, or it can extend into delicate movements, such as threading a needle or plucking a string. It can grasp tools, create art, and express emotion through gesture. The bones of the hand are the foundation of these actions, their structure giving rise to one of humanity's most distinctive abilities. The upper limb is not only functional but expressive. Through the arms and hands, people communicate as much as through words. A wave, a touch, a gesture, all are made possible by the framework of bone beneath. The arm extends outward in offering. The hand curves into a caress. The fingers shape symbols and signs. In this way, the upper limb is not only an instrument of survival but also of expression, connecting the inner life to the outer world. The shoulder joint, elbow joint, and wrist joint each contribute to this expression. The shoulder allows broad motion, the elbow provides strength and precision, and the wrist and hand offer subtlety. Together, they create a continuum of movement, from sweeping gestures to the smallest flick of a fingertip. The bones, ligaments, and muscles of the upper limb work in harmony, turning intention into action. It is also important to reflect on the balance of strength and delicacy in the upper limb. The humerus, radius, and ulna are strong bones, built to withstand the forces of lifting, pushing, and pulling. The carpals, metacarpals, and phalanges, though smaller, provide agility. This balance allows the arms to perform tasks both great and small, to carry burdens yet also to create with care. The upper limb is therefore not one-sided but balanced, designed for versatility. Through life, the upper limbs serve as constant companions. In childhood, they explore the world, reaching outward in curiosity. In adulthood, they labor, create, and embrace. In later years, they may tire, yet they remain expressive, still capable of gesture and touch. The bones within them, silent and enduring, carry the story of every action, every movement, every creation. As you reflect on the upper limbs, you might imagine them as branches extending outward from the trunk of the body. The humerus is the great branch, strong and long. The radius and ulna are the smaller branches that twist and adapt. The carpals and fingers are the twigs at the ends, delicate and fine, reaching outward into space. Together, they form a living extension of the self, expressive and strong, graceful and precise. The upper limb is therefore more than a collection of bones. It is the architecture of action, the framework of expression. Through it, the body reaches into the world, shaping, creating, and connecting. It is the quiet structure behind every gesture, every embrace, every work of art, and every act of daily life. 15. The pelvic girdle. If the shoulder girdle is light and free, allowing the arms to move with wide arcs of motion, the pelvic girdle is its opposite, heavy, stable, and firmly anchored. It is the great basin of the body, the structure that supports weight, protects organs, and provides the foundation for upright posture. Where the shoulders are built for freedom, the pelvis is built for endurance. It is the anchor of the lower body, connecting the spine above to the legs below, and through it the entire weight of the trunk is carried into the ground. To reflect upon the pelvic girdle is to consider the body's strength at its deepest core, the balance of stability and protection. The pelvic girdle is formed by two large bones, each known as a hip bone or coxal bone. These bones are not single pieces at birth, but are created from three parts: the ilium, the ischium, and the pubis. During childhood and adolescence, these three parts are joined by cartilage, and as the body matures, they fuse together into one solid structure. In adulthood, the hip bones stand as strong, unified supports to form the broad ring of the pelvis. At the back, each hip bone joins with the sacrum, completing the connection between the axial and appendicular skeletons. At the front, they meet at the pubic symphysis, a joint of cartilage that gives the pelvis both strength and slight flexibility. Each part of the hip bone has a unique role. The ilium is the broad, flaring portion at the top, easily felt beneath the skin as the curved crest of the hip. It provides a wide surface for muscle attachment and helps form the walls of the pelvic basin. The ischium, located at the lower back portion, is the part of the bone upon which the body rests when sitting. Its roughened surface bears the weight of the torso, acting as a seat of bone. The pubis, at the front, forms the anterior portion of the pelvis. The two pubic bones meet at the pubic symphysis, a joint cushioned by cartilage that allows for slight movement, especially important during childbirth. Together, the ilium, ischium, and pubis form the ring of the hip bone, each contributing to its strength and function. At the outer side of each hip bone lies a deep socket called the acetabulum. This is where the head of the femur fits, forming the hip joint. Unlike the shallow glenoid cavity of the shoulder, the acetabulum is deep and firmly cupped, holding the femur securely in place. This design ensures stability, for the hip must bear the full weight of the body during standing, walking, and running. While it sacrifices some freedom of movement compared to the shoulder, it gains strength and endurance. The hip joint allows flexion, extension, rotation, and some lateral movement, but always with the assurance that the leg remains firmly anchored. Beneath the acetabulum lies another notable feature, the obturator foramen. This is a large opening formed by the pubis and ischium, covered by a thin membrane and crossed by blood vessels and nerves. Though it may appear as a gap, it is not a weakness, but a clever adaptation, reducing the weight of the pelvis while still providing passage for vital structures. These openings, one on each side, are among the largest in the human skeleton, reminders of how design balances strength with lightness. The pelvis as a whole is often described as a basin, and indeed its shape cradles many of the body's organs. Within its ring lie the bladder, portions of the intestines, and in females, the reproductive organs. The pelvic girdle thus serves not only as a support for the body above and a foundation for the legs below, but also as a protective cradle for the organs within. The bones shield these structures, surrounding them in a basin of strength. There are differences in the shape of the pelvis between males and females, reflecting the differing needs of the body. In general, the female pelvis is broader and more circular, with a wider opening to facilitate childbirth. The male pelvis is narrower, more robust, and taller, built for greater strength and support. These differences are subtle in some cases, more pronounced in others, but always they reflect the balance between the universal design of the skeleton and the particular needs of the body. The pelvic girdle also plays a vital role in posture and balance. By connecting the spine to the legs, it allows the human body to stand upright with efficiency. The curves of the sacrum, the slope of the ilium, and the placement of the hip sockets all work together to distribute weight evenly. When walking, the pelvis shifts gently from side to side, balancing each step. When sitting, it supports the torso. When standing still, it steadies the body against gravity. It is the quiet fulcrum of balance, always adjusting. Muscles attach in great number to the pelvic girdle. The gluteal muscles, among the largest in the body, arise from the ilium and spread into the thighs, powering motion and providing strength. The abdominal muscles attach at the pubis, shaping the core and supporting the organs within. Ligaments also play their part, binding the pelvis to the sacrum and femur, ensuring stability in every posture. The pelvis is therefore not an isolated structure but a hub, where many of the body's strongest muscles converge. Throughout life, the pelvic girdle remains a symbol of endurance. In childhood, it is still forming, its three parts joined by cartilage. In adulthood, it carries the full weight of the body, bearing the strain of motion and labor. In later years, it may change in density and shape, but its role endures, always grounding, always supporting, always carrying. When viewed in the larger design of the skeleton, the pelvis is the foundation of the lower body. It is the base from which the legs extend, the seat of stability, the basin of protection. It complements the shoulder girdle, balancing the lightness of the arms with the strength of the legs. Together, the two girdles reflect the dual nature of the appendicular skeleton: mobility above, stability below, freedom above, support below. As you reflect on the pelvic girdle, imagine it as the deep root of the body, anchoring you firmly to the ground. Its wide bones are like the base of a great tree, spreading outward to support the trunk above. Its basin is like a quiet cradle, holding what is vital within. Through it, the body finds its strength, its balance, and its connection to the earth. It is not often thought of, yet it is always there, steady and enduring, the silent foundation upon which the body stands. 16. The lower limb, where the upper limb is light and expressive, made for gestures, fine motion, and creation. The lower limb is built for power, endurance, and support. It is the framework that allows humans to walk upright, to run across open ground, to climb in balance, and to carry the full weight of the body against gravity. The bones of the legs and feet are among the strongest in the skeleton, for they must bear the constant burden of locomotion. Yet they are not merely heavy beams of support. They are shaped with grace, arranged to absorb impact, distribute weight, and propel the body forward with fluid efficiency. To reflect upon the lower limb is to contemplate the quiet strength that carries every step of life's journey. The lower limb, like the upper, is divided into regions: the thigh, the leg. Each region is built upon long bones that provide leverage and strength, supported by joints that allow motion and stability. The thigh contains a single bone, the femur, which is the largest and strongest bone in the human body. Its size reflects its role, for it bears more weight than any other. At its upper end, the femur forms the rounded head that fits into the acetabulum of the pelvis, creating the hip joint. This joint is deep and secure, built for stability. It allows movement in many directions: forward, backward, sideways, and in rotation, but always with the assurance that the leg will remain firmly anchored. The shaft of the femur is long and slightly curved, shaped to distribute forces evenly as the body moves. Along its surface, powerful muscles attach, including the great quadriceps of the front and the hamstrings of the back. At its lower end, the femur widens into condyles, smooth, rounded surfaces that meet the tibia at the knee joint. Between them lies the patella, or kneecap, a small triangular bone embedded within the tendon of the quadriceps. The patella acts like a shield, protecting the joint, and also serves as a lever, increasing the efficiency of the thigh muscles. Together, the femur and patella form the upper part of the knee, a joint both strong and complex. Below the knee lie the bones of the leg, the tibia and fibula. The tibia, also known as the shin bone, is the larger of the two and bears almost all of the body's weight. It extends downward from the knee to the ankle, its broad surface supporting the femur above. The tibia's upper end forms the lower half of the knee joint, while its lower end forms the inner ankle bone. Alongside the tibia lies the fibula, slender and delicate in comparison. Though it bears little weight, the fibula provides important support, serving as an anchor for muscles and helping stabilize the ankle. Together, the tibia and fibula create a framework that balances strength with stability, ensuring that the lower leg can both support and adapt to movement. At the base of the leg lies the foot, one of the most intricate structures of the skeleton. Each foot contains 26 bones, arranged into 3 regions: the tarsals, metatarsals, and phalanges. The tarsals form the ankle and heel, 7 bones in all. Among them, the talus stands at the top, meeting the tibia to form the ankle joint. The calcaneus, or heel bone, lies just below, projecting backward to bear weight and provide leverage for walking. Other tarsals, such as the navicular, cuboid, and cuneiforms, form the arch of the foot, distributing pressure and absorbing shock. Beyond the tarsals lie the metatarsals, 5 long bones that form the midfoot. These bones support the arches and provide the framework for balance. At their ends lie the phalanges, the bones of the toes. Each toe has 3 phalanges, proximal, middle, and distal, except for the great toe, which has only 2, though smaller and less mobile than the fingers. The toes play a vital role in walking, helping to push the body forward with each step. The entire foot, with its many bones, forms a structure of resilience, built to endure countless miles across a lifetime. One of the most remarkable features of the foot is its system of arches. The longitudinal arches run along its length, one on the inner side and one on the outer. The transverse arch runs across its width. These arches act as springs, compressing slightly under weight and rebounding with each step. They reduce the impact of walking and running, protect the bones from strain, and give the foot both strength and flexibility. Without them, the foot would be flat and inefficient, less able to carry the weight of the body with ease. The joints of the lower limb are built for both motion and strength. The hip joint, deep within the pelvis, provides stability for standing and walking, while still allowing a wide range of motion for sitting, bending, and turning. The knee joint, the largest in the body, is a hinge that allows bending and straightening, with additional structures such as ligaments and menisci that provide stability. The ankle joint, at the base of the leg, allows the foot to flex upward and downward, adapting to uneven ground. Together, these joints ensure that the lower limbs can carry the body across varied terrain, always balancing strength with flexibility. The lower limb also reflects the history of human evolution. In most animals, limbs are used for walking on all fours, sharing weight between fore and hind legs. In humans, the lower limbs alone bear the weight of bipedal locomotion. This adaptation has shaped the pelvis, femur, knee, and foot into forms that support upright posture. The angle of the femur, the locking mechanism of the knee, and the arches of the foot all work together to make walking on 2 legs efficient. Within these bones lies the story of humanity's unique way of moving, the story of standing tall upon the earth. In daily life, the lower limbs serve constantly, often without thought. They carry the body from place to place, steady it in stillness, and propel it in motion. They support the weight of labor, bear the strain of lifting, and endure the shocks of walking and running. And yet, they also express grace, whether in the rhythm of dance, the quiet poise of standing, or the fluid motion of stride. The bones of the lower limb, though unseen, are the hidden framework of this endurance and grace. As you reflect upon the lower limbs, imagine them as pillars extending downward from the pelvis, strong and steady. The femur is the great column of the thigh, the tibia the strong beam of the shin, the fibula the slender support at its side. The foot spreads like a foundation, its arches lifting and curving to absorb the weight above. Together, they form a living architecture, grounding the body, carrying it across the earth, and supporting it through the journey of life. The lower limb is, in essence, the strength of the skeleton made visible. It is the silent bearer of weight, the foundation of motion, the enduring support of the human form. Every step, every stride, every moment of standing tall depends upon its bones. They are the quiet pillars of existence, steady and enduring, carrying the body with strength and grace through every day and every night. 17. Joints of the skeleton. While bones form the structure of the body, they cannot act alone. If the skeleton were made of solid, fused parts, the body would be rigid and still, unable to bend or move. What gives the skeleton its grace and mobility are the joints, the places where bones meet. Joints are the quiet hinges, pivots, and gliding points of the body. They allow us to move with freedom, to bend forward, to stretch upward, to turn and rotate, and to walk with rhythm. Without them, the skeleton would be only a cage of stillness. With them, it becomes a living instrument of motion. Joints are found wherever two or more bones come together. Some are fixed and immovable, holding bones firmly in place. Others are slightly movable, allowing a small degree of flexibility. Still others are freely movable, creating the wide range of motion we experience every day. This variety of joints reflects the different needs of the body, sometimes for stability, sometimes for motion, and often for a balance of both. The immovable joints are called fibrous joints. These are found where bones are joined tightly by connective tissue, allowing no motion. The sutures of the skull are the best example. Here, the bones are locked together in firm seams, protecting the brain by ensuring that no movement can separate them. Though they are immobile, these joints serve a profound purpose. They provide absolute stability where protection is needed most. In early life, they are not yet fused, allowing for growth and flexibility, but in adulthood, they become fixed, securing the cranium as a strong shield. Slightly movable joints are known as cartilaginous joints. In these, bones are joined by cartilage, allowing limited motion. The joints between the vertebrae of the spine are examples of this type. The intervertebral discs of cartilage permit gentle bending and twisting while also cushioning impact. Another example is the pubic symphysis, where the two halves of the pelvis meet. This joint allows only a small degree of flexibility, but that slight movement is vital, particularly during childbirth. These joints demonstrate that not all motion must be wide or obvious. Sometimes the quietest degrees of flexibility are the most essential. The most versatile joints are the synovial joints, which are freely movable. These make up the majority of the joints in the body, and are the reason we can move with such variety. Synovial joints are enclosed within a capsule filled with synovial fluid, a clear liquid that lubricates the joint, reducing friction and nourishing the cartilage. The surfaces of the bones are covered with smooth cartilage, ensuring that they glide against one another with ease. This combination of fluid, cartilage, and capsule creates joints that are strong, resilient, and supple, capable of enduring countless motions throughout a lifetime. Synovial joints come in many forms, each shaped to allow a specific type of movement. The hinge joint, for instance, permits bending and straightening in one direction, like the hinge of a door. The elbow and the knee are hinge joints, powerful and precise. The pivot joint allows rotation, as seen between the first two vertebrae of the neck, where the atlas rotates around the dens of the axis to turn the head side to side. The ball and socket joint, one of the most mobile forms, allows movement in nearly every direction. The hip and shoulder are ball and socket joints, with the rounded head of one bone fitting into the socket of another. This design grants freedom, though with different balances. The hip joint is deep and stable, the shoulder joint shallow and flexible. Other synovial joints include the saddle joint, found at the base of the thumb, which allows the thumb to oppose the fingers, a movement central to human dexterity. The condyloid joint, such as the one at the wrist, allows bending, straightening, and side-to-side movement. The plane joints, or gliding joints, permit sliding motions, as in the small bones of the wrist and ankle. The diversity of these joints shows how form and function are married in the skeleton, each type adapted to the needs of its place. Joints are not only bones and cartilage, but are also supported by ligaments and tendons. Ligaments are strong bands of connective tissue that connect bone to bone, holding joints together while still allowing motion. They ensure that joints do not move too far, keeping the skeleton stable. Tendons, on the other hand, connect muscles to bone, transmitting the force of contraction into movement. Together, ligaments and tendons make joints both strong and functional, balancing flexibility with control. The importance of joints is perhaps most easily felt in daily life. Each time you bend to sit, stand, or walk, your knees and hips move in harmony. Each time you reach or grasp, your shoulders, elbows, and wrists align in fluid sequence. Even small motions, turning the head, flexing a finger, shifting the foot, are the work of joints. They are the unseen hinges of existence, quietly shaping every movement. Joints also reflect the passage of time. In youth, they are supple, well-cushioned, and resilient. In adulthood, they carry the burden of labor, adapting to the stresses placed upon them. In later years, they may grow stiffer as cartilage wears and ligaments lose elasticity. Yet even then, their role endures, allowing motion, however gentle. The story of a life is written not only in bones but also in joints, in the way they move and in the way they adapt. It is striking to consider how joints embody balance. Too much rigidity would confine the body. Too much looseness would leave it unstable. Joints find the middle path, offering both freedom and restraint, both movement and stability. This balance is not something we think about as we go about our day, but it is always there, guiding the body through its motions. As you reflect upon the joints of the skeleton, you might imagine them as quiet hinges and pivots, hidden yet essential. The knees bend like doors opening. The shoulders circle like wheels. The wrists glide like smooth stones across water. Each joint is a meeting place where bone and motion converge. They are the soft-spoken companions of life, unnoticed yet indispensable, turning the rigid framework of the skeleton into a living, moving body. In essence, the joints of the skeleton transform stillness into motion. They allow the body to walk, to reach, to embrace, and to create. They balance freedom with strength, silence with action. They are the hidden grace of the skeleton, the points of connection that turn structure into life. 18. The microscopic view of bone. Up to this point, we have explored the skeleton as it appears on the scale. We can see the great arcs of the rib cage, the long span of the femur, the delicate structures of the hand. Yet within each bone lies another world, one invisible to the eye but no less real. It is a world of intricate patterns, of cells and channels, of networks that sustain life. To see bone under the microscope is to discover that even the hardest, most silent part of the body is alive with hidden architecture. This microscopic view reveals how bones are nourished, how they grow, and how they endure. The outermost layer of bone is called compact bone. It is dense, smooth, and strong, forming the hard shell that gives bones their firmness. But when examined closely, compact bone is not solid at all. It is organized into repeating units known as osteons, also called Haversian systems. Each osteon is like a cylinder, arranged parallel to the long axis of the bone. At its center lies the Haversian canal, a narrow channel through which blood vessels and nerves run. Around this canal are concentric rings of bone tissue, called lamellae. Within these rings, small spaces called lacunae hold bone cells, or osteocytes. Tiny channels called canaliculi connect the lacunae, allowing nutrients and signals to flow from cell to cell. This arrangement is elegant and efficient. The osteon ensures that every bone cell lies close to a blood supply, even deep within the compact tissue. Through the canaliculi, osteocytes communicate, sensing stresses placed upon the bone and signaling for repair or reinforcement. The osteon is therefore not just a structural unit, but a living community of cells, supported by a web of channels. It is through these microscopic systems that bone remains alive, responsive, and resilient. Beneath the surface of compact bone lies another type of structure, spongy bone, also known as cancellous bone. Despite its name, spongy bone is not weak but highly specialized. It is arranged into a network of thin struts, called trabeculae, which form a lattice-like pattern. These trabeculae are aligned along the lines of stress within the bone, ensuring strength with minimal weight. The open spaces between them are filled with marrow, blood vessels, and connective tissue. This design makes spongy bone light yet strong. Like the framework of a bridge, it is found in regions where bones must be both sturdy and adaptable, such as the ends of long bones, the pelvis, and the vertebrae. Within the cavities of bone lies marrow, a soft tissue with vital functions. In children, much of the marrow is red marrow, the site where blood cells are produced. Here, stem cells give rise to red blood cells, which carry oxygen, white blood cells, which defend against illness, and platelets, which aid in clotting. In adults, red marrow is found mainly in the pelvis, ribs, sternum, and ends of long bones. Elsewhere, the marrow becomes yellow marrow, rich in fat, serving as an energy reserve. Yet even yellow marrow retains the ability to shift back into red marrow if the body requires more blood production. Thus, bone is not only a structure of support but also a cradle of life, producing the very cells that flow through the body each moment. The microscopic world of bone is also home to its dynamic cycle of renewal. Osteoblasts, the builders, secrete the organic framework of bone, laying down collagen fibers that form a soft scaffold. Onto this scaffold, minerals such as calcium phosphate are deposited, hardening the tissue. Osteoclasts, the recyclers, dissolve old bone, breaking down its minerals and releasing them into the blood. Osteocytes, mature bone cells resting within their lacunae, act as overseers, sensing when stress demands reinforcement or when damage must be repaired. This constant interplay ensures that bone is never static but always renewing itself, replacing old with new, maintaining strength and balance. It is remarkable to realize that this process unfolds continuously, even in moments of stillness. As you sit or lie and rest, microscopic cells within your bones are at work, breaking down small sections, rebuilding others, reinforcing regions that bear weight, and restoring areas that have suffered micro-damage. This quiet labor prevents bones from becoming brittle or worn, allowing them to endure the countless stresses of daily life. It is a rhythm hidden beneath awareness, a cycle that continues throughout life. Bone tissue also serves as a reservoir for minerals, particularly calcium and phosphorus. These minerals are essential not only for the hardness of bone but also for vital processes elsewhere in the body. Calcium, for example, is needed for muscle contraction, nerve signaling, and blood clotting. When blood calcium levels fall, osteoclasts break down bone to release calcium into the circulation. When levels rise, osteoblasts store the excess back into bone. In this way, bone acts as a quiet regulator, maintaining the balance of minerals in the body. It is not only a support but also a silent participant in the chemistry of life. Under the microscope, even the smallest details of bone reveal purpose. The alignment of trabeculae in spongy bone matches the forces of daily movement, adapting constantly to changes in stress. The arrangement of osteons in compact bone ensures both strength and nourishment. The marrow spaces hum with activity, producing new cells each day. The cells themselves, though microscopic, are active agents building, sensing, and reshaping. This hidden world transforms the idea of bone from something inert to something vibrant, endlessly alive. The microscopic structure also explains the resilience of bone. A bone may seem hard and unyielding, yet it is composed of both mineral and protein. The mineral gives rigidity. The collagen provides flexibility. Together, they create a tissue that is hard, yet slightly elastic, capable of bending without breaking under ordinary stress. This balance is reflected in the smallest structures: collagen fibers woven through lamellae, minerals crystallized upon them, cells monitoring and maintaining the design. The strength of the skeleton, visible on the grand scale, begins here, in the microscopic harmony of mineral and matrix. As you reflect upon the microscopic view of bone, imagine it as a hidden city beneath the surface. The osteons are its towers, the canals its streets, the cells its quiet inhabitants. Blood vessels flow like rivers, carrying nourishment, while canaliculi connect each dwelling with another, allowing constant communication. The trabeculae of spongy bone form its bridges and arches, light but strong, surrounding the marrow, where life is born each day. This city is never silent, never still, always working, always alive. In essence, bone on the microscopic scale is both architecture and activity. It is a structure of repeating patterns, elegant and efficient, and also a community of cells, dynamic and responsive. It reminds us that even the hardest parts of the body are living, that even in stillness, life flows unseen. To look closely is to discover that within every bone, strength is not only in hardness but in the ceaseless rhythm of renewal. 19. Bone health across life. The story of bone is not one of stillness but of change. From the soft and flexible framework of infancy to the solid strength of adulthood, and finally to the lighter, more fragile structure of later years, bones reflect the passage of life. They grow, they remodel, they strengthen, and eventually, they yield. To consider bone health across life is to trace a journey, one shaped by nourishment, by movement, by hormones, and by time itself. The skeleton is not merely a framework of support, but a living record of life stages, adapting to the needs of the body in each season. In the earliest years, bones are soft and pliable, composed largely of cartilage. At birth, many parts of the skeleton have not yet hardened. The skull, for example, has soft spaces called fontanelles, allowing flexibility during birth and room for the brain to grow. The long bones contain growth plates, bands of cartilage at their ends, where new bone is added, lengthening the limbs year by year. During childhood, these growth plates remain active, and bones grow longer and denser, responding to both nutrition and movement. Children's bones are also more flexible than adults, able to bend slightly under stress without breaking. This pliability protects them, allowing the skeleton to adapt to the rough and energetic motions of youth. As adolescence approaches, bone growth quickens. Hormones play a vital role here. Growth hormone stimulates lengthening, while sex hormones, such as estrogen and testosterone, increase density and shape. This is the time of growth spurts, when the skeleton stretches taller in what seems like sudden leaps. Muscles strengthen, and bones respond by thickening, adapting to the forces placed upon them. By late adolescence, the growth plates gradually close, fusing into solid bone. Height ceases to increase, but bone density continues to build, reaching its peak in early adulthood. This stage, known as peak bone mass, represents the strongest the skeleton will ever be. In adulthood, the skeleton is steady but still dynamic. Bones no longer lengthen, but remodeling continues constantly. Osteoblasts lay down new tissue, osteoclasts remove old tissue, and osteocytes monitor the balance. Physical activity plays a key role in this stage. Weight-bearing exercises, such as walking, climbing, or lifting, stimulate bones to grow denser. Without such activity, bones lose strength, as the body senses no need for heavy reinforcement. Nutrition is also vital. Calcium provides the mineral backbone of bone, while vitamin D ensures that calcium is absorbed and used effectively. Protein, phosphorus, and magnesium contribute as well. In adulthood, lifestyle choices leave clear marks on bone health. Choices of diet, exercise, rest, and balance. Yet even in this stage, bones remain vulnerable to shifts. Hormonal changes, illnesses, or lack of nutrition can weaken them. For women, estrogen plays a protective role in maintaining bone density. After menopause, when estrogen levels decline, bones may lose strength more quickly, leading to conditions like osteoporosis, where bones become thin and brittle. Men, too, experience gradual changes, though often later and slower. This transition reminds us that bone health is not fixed but always in flux, dependent on the quiet interplay of hormones, activity, and nourishment. In later life, bones grow lighter, remodeling continues, but the balance tips toward resorption rather than building. Osteoclasts remove more bone than osteoblasts replace, and density decreases. The spongy bone, with its trabecular lattice, thins, and the compact bone becomes more brittle. Fractures become more likely, especially in the hips, spine, and wrists. The spine may compress, leading to a shorter stature or stooped posture. The rib cage stiffens as cartilages harden, making breathing slightly less flexible. Yet even in this stage, bones remain adaptable. Gentle exercise, proper nourishment, and careful care can slow the loss, preserving strength and mobility. Across all stages, the health of bone is deeply tied to balance. Balance between building and breaking down, between movement and rest, between nourishment and need. It is also shaped by the invisible chemistry of hormones and minerals. Calcium and vitamin D are perhaps the most familiar, but many others play quiet roles. Parathyroid hormone regulates calcium release, calcitonin helps deposit it, and growth factors guide remodeling. Each signal, each nutrient, is part of the hidden conversation that sustains the skeleton. The environment, too, leaves its mark. Sunshine provides vitamin D through the skin, strengthening bones indirectly. Diets rich in leafy greens, dairy, nuts, and grains feed the skeleton daily. Activity provides the stress that bones need to grow dense. A reminder that bones thrive not in stillness but in motion. Even posture, the way the body is held, shapes the skeleton over time, for bones respond to the forces they carry. Bone health is also a matter of repair. Throughout life, bones suffer small stresses, microfractures invisible to the eye. Each one is healed by the remodeling process, repaired and renewed. Larger fractures, though painful, can also heal fully, as new bone replaces old. This capacity for self-repair is one of bone's greatest strengths. Yet with age, the process slows, and healing takes longer. Still, the capacity never disappears, a quiet resilience that endures throughout life. To reflect on bone health across life is to see the skeleton as a lifelong companion, changing but always present. In youth, it is soft and growing. In adolescence, it stretches and strengthens. In adulthood, it balances and adapts. In later years, it grows lighter, yet it still carries, still protects, still supports. Each stage brings its own challenges and its own quiet strengths. The skeleton is not a static framework, but a living story, written across the years in growth, density, and endurance. As you rest, you might imagine your bones not as hard and lifeless, but as living companions shaped by time. In childhood, they were flexible, bending without breaking. In youth, they lengthened and grew. In adulthood, they carried weight and adapted to stress. In later years, they softened, yet they remained faithful, still holding, still supporting. They are the silent record of life's journey, responding to every stage with grace. In essence, bone health across life is a story of change. It is the story of growth and strength, of balance and adaptation, of lightening and resilience. It is the story of how the skeleton supports the body not only in space but in time, and it is a reminder that beneath every step, every gesture, every breath, the bones endure alive, adapting, and always with us, from the first day to the last. 20. Closing reflections. As we arrive at the conclusion of this journey through the skeleton, it is calming to let the entire structure unfold in the mind's eye. We began at the top, with the skull, the shield, and cradle of thought. We traced the spine, the silent column carrying both the body's weight and the delicate spinal cord. We paused with the rib cage, a curved shelter breathing softly with life. From there, we extended outward to the arms and hands, the light, expressive upper limbs, then downward to the hips, legs, and feet, the enduring pillars that carry us. We turned inward to the microscopic view, discovering bone as a living city of cells and channels. Finally, we traced the arc of life itself, from the flexible bones of infancy to the lighter framework of later years. Now, at this quiet end, we gather all these parts together and see the skeleton not in fragments but as a whole. The skeleton, when taken as one, is an architecture of balance. It is both shield and lever, both foundation and expression. It is protective in the skull and ribs, powerful in the legs, dexterous in the hands. It stands as the central pillar in the spine, but also reaches outward in the limbs. Each bone has its own role, yet all work together, forming a unified structure that sustains life. The skeleton is not simply scaffolding, it is a living framework, adapted to every demand placed upon it. It is easy, in daily life, to forget the skeleton's presence. We think of skin, of muscles, of breath, but the bones remain silent. They are unseen, hidden beneath layers of tissue, rarely noticed unless injured or revealed in medical images. Yet their silence is part of their gift. They do not call for attention. They simply endure. They support without asking. They protect without complaint. They repair themselves when damaged. The skeleton is perhaps the most faithful companion in the body, always present, always working, never demanding thanks. The beauty of the skeleton lies in its balance of strength and lightness. Bones are strong enough to resist pressure, yet light enough to allow motion. Their outer layer of compact bone gives hardness, while the inner lattice of spongy bone reduces weight while maintaining resilience. Long bones provide leverage. Flat bones provide protection. Irregular bones carry out specialized functions. Even the smallest bones, such as those of the middle ear, have precise purposes, transmitting sound, so that hearing may occur. Every contour, every hollow, every curve is purposeful, contributing to the harmony of the whole. The skeleton is also a quiet witness to time. In the bones are written the years of growth, of motion, of labor. Children's bones hold growth plates, widening and lengthening. Adult bones show density, remodeled by the stresses of activity. Elderly bones lighten, revealing the gradual shift of age. In archaeology, bones reveal the stories of ancient lives, height, diet, health, even the strain of daily work. On the personal scale, they tell the story of each individual life. In this way, the skeleton is not only structure but memory, recording the traces of time with quiet accuracy. And though it seems unmoving, the skeleton is alive with change. Cells labor constantly within it, breaking down and rebuilding. Marrow produces blood, sustaining the circulation of life. Minerals move in and out, balancing the chemistry of the body. With each step, bones sense the pressure of weight and respond by strengthening themselves. With each rest, they continue their repair. This cycle never stops, continuing from the first days of growth until the final moments of life. It is humbling to remember that even as you rest in stillness, your bones are quietly renewing themselves. The skeleton is also a reflection of humanity's place in the living world. Its upright posture, shaped by the spine and pelvis, is unique among most creatures. Its hands, with opposable thumbs, allow tools, writing, and creation. Its feet, with strong arches, allow walking across long distances. These adaptations have shaped human history, allowing exploration, community, and survival. Within the bones lies the long story of life's evolution, a story that stretches back through countless generations, connecting the present body with ancient forms. There is also a poetry in the way the skeleton balances protection and vulnerability. The skull shields the brain, yet has openings for nerves and senses. The rib cage protects the heart, yet must remain flexible to breathe. The spine encases the spinal cord, yet bends and twists to allow motion. The shoulder allows freedom, yet sacrifices stability. The hip sacrifices freedom, yet provides stability. In every region, there is balance, strength paired with softness, mobility paired with restraint. This duality makes the skeleton not only functional but graceful. As we step back and view it as a whole, the skeleton resembles many things. It is like a cathedral, with arches of ribs, columns of legs, a dome of the skull, and a central nave of the spine. It is like a tree, with the trunk of the spine and the branches of arms and legs, rooted in the pelvis, reaching outward and upward. It is like a city, where cells labor quietly, building, repairing, renewing, with blood vessels as roads and marrow as the cradle of new life. Each of these images captures something true, for the skeleton is both structure and story, both biology and poetry. As you reflect on the skeleton now, in this quiet moment, imagine it not as something distant or clinical, but as your own faithful architecture. Imagine the skull, resting like a calm dome above. Imagine the spine, rising like a steady pillar through the center of your body. Imagine the rib cage, expanding and contracting softly with each breath, a dome that shelters your heart and lungs. Imagine the pelvis, strong and grounding, anchoring you to the earth. Imagine the legs, like columns, bearing you forward, and the arms, like branches, reaching outward into the world. All of this lives within you, silent but enduring. The skeleton, at the end of this long exploration, reveals itself as more than anatomy. It is a reminder of resilience, of balance, of endurance. It is a reminder that strength is not only in hardness, but also in flexibility, not only in stability, but also in the ability to adapt. It shows that what endures is not static but living, always renewing itself, always responding, always present. So, as this journey draws to a close, let the thought of your skeleton bring calm. Beneath the surface, it is there, steady and strong, carrying you without effort, supporting you in silence. It has grown with you, healed for you, and endured for you. It is your quiet companion, faithful from the beginning to the end. And in its silence, it teaches something simple yet profound, that strength can be quiet, that endurance can be gentle, and that life is held together by structures we rarely see, but always carry. As you drift into rest, imagine your skeleton at peace, strong, steady, alive, and whole. The cathedral of bone is quiet. The city within it is working softly. The branches are still. You are supported. You are sheltered. And you are carried. The skeleton endures, and with it, so do you.